So in today's session, we'll discuss about previous year questions of network theory, and I have selected questions from last 5 years. So we'll try to solve questions from last 5 years, from 2022, then 21, and then 20, 19, 18. Okay, so we will cover all these questions. Good evening, Raghuram. Good evening, everyone. So I hope you'll understand some new concept in this session, and I hope you will enjoy today's session. Okay, so let's begin the session. So before starting the session, I want you to subscribe this channel because this is important. Okay, so make sure ki you subscribe this channel and like this session if you haven't liked it. So please like it and press the bell icon so that you get the notification whenever some live lecture is there. Then you'll get the notification. Maha Marathon series is going to start from 3rd of January. So you can tell to your friends also. You can recommend this series to your friends also. So this is a, you can say, big step and kind of revision for your entire subject revision. It's very important. So you can attend this series and it will start from 3rd of January. Okay. For GATE 2024 students, there are some, you can say, workshops are going on. Like on 20th December there was one workshop. So similarly there will be more workshop on for GATE 2024. So if your friend or if your junior is going to start the preparation for GATE 2024, you can recommend this workshop. You can register yourself. The link is given in the description. Okay, so let's proceed. So this is GATE PYQ series which is going on. But let me tell you guys, it's time to give the test series, because now you have to perform the test series. Test series is very important part, and it will tell you what kind of mistakes you are doing. Okay, so please join the test series, and BYJU'S Exam Prep is also providing you the test series. So join it, start giving the test, and I hope you will analyze your preparation and you will get your mistakes. You'll find your mistakes. You'll check your speed and accuracy. So it's important. You can join this test series in BYJU'S Exam Prep. You'll get the test series in which you'll get 60 plus test, and there will be some mock test. So it's a good part. So start giving the mock test, analyze yourself. Don't check the rank, because rank is not the correct idea to check in the test series. Okay, but check your mistakes. This is important. Okay, so please join this test series, guys. Okay, so let's start the questions. Let's start solving the questions. Okay, so tell me, guys, is audio video clear to everyone? Audio video clear to everyone? Tell me. Please reply in the chat section. Say yes, Y for yes, N for no. Okay, say Y for yes, N for no. Let's start the session. Is audio video clear to everyone? Tell me, guys. Can I start? Okay. First of all, my health is not with me, so it might be possible that because actually there are like approximately 30 questions I have selected, but it might be possible that I may not complete all the 30 questions because I'm not feeling well. I have fever and cough and cold, so you can say 3-in-1 disease are there. So I will try to maximize the question. Okay, I mean there are 30 questions, so approximately I'll try to solve 20 approximately. So let's see how much questions I can solve in this session. So at least 1.5 hour I'll be there. Okay, so let's start solving the question, guys. So this is my first question. There were some questions in which I will tell you the process only, because the calculation part is just boring, and I think you can calculate yourself. The method is important. So there were some questions in which I'll tell you the method only. Okay, you can process and you can proceed the calculation and you can get the answer. Okay, so sorry from my side because I have to cover almost 30 questions. That's the reason. So there will be some questions in which I'll tell you the approach, not the final answer. Okay, so please. Now this is the first question, and in this question the circuit shown below, a three-phase. This is 2022, GATE 2022. Now this question belongs to electrical branch, because if you are from EC branch then you can skip this question because three-phase circuit is not included in your branch. So but the next question it will be included in EC also. So there will be some questions which are included in both EC and EE, okay, and IN. So you can also watch those questions, okay? But this question is specially for electrical engineering and IN, because in EC 3-phase circuit is not included. Also mention which year it was given, branch and ESL. Okay, this is GATE 2022 and 2 marks question. Okay, let's start this question, guys. For EC student, you try to solve this question. Okay, let me give you first. This is the question that I mean for EC, because it's just the time waste for EC, na? So if you are from EC branch, start solving this question. In this question, what is given? An inductor having Q factor of 60 is connected with a capacitor having Q factor of, let me give you the capacitor Q factor. I think there is a typing mistake. Wait a minute, let me check the capacitor Q factor so that I can send you. Wait a minute. Yes, an inductor having Q factor of 60 connected in series with a capacitor having a Q factor of, I think again it's a mistake. Please check the GATE 2022 question, guys, because I think this question is not complete. Okay, this is for both EE and EC. Please check original question, GATE 2022. I think this statement is missing. Something is missing in this statement. This is GATE 2022. GATE 2022 EE. Okay, this is EE question. Please check the complete statement, because I think the quality factor of capacitor should also be provided here. Okay, and then the overall Q factor is asked. Okay, this is the original question. So EC student, please try to solve this question. Till then I can solve this question for EE student. The circuit shown below, a 3-phase star connected unbalanced load is connected to a balanced 3-phase supply. Okay, 3-phase supply is balanced and this voltage is 10√3 volt. This is 10√3 volt. It is provided to us, okay, with the phase sequence ABC. Now what is the meaning of phase sequence? It is given that the Q factor of 240. Okay, here the capacitor has Q factor of 240. Okay, I think Ravi Shankar is saying that the capacitor has the Q factor of 240. Okay, now find the overall Q factor. Now for EC student, please try this question. Till then I can solve this question. Okay, so for EE and IN student, please be focused. So in this question, 3-phase source is balanced and the phase sequence is ABC. So it is given that the RMS value of the source voltage, phase voltage, is 10√3. Okay, balanced 3-phase supply of 10√3 volt with phase sequence ABC. Since it is not given that this is the phase voltage, it is only given that the circuit shown below, a 3-phase star connected unbalanced load is connected to a balanced 3-phase supply of 10√3 volt. It means it is not necessary that 10√3 is this phase voltage. It might be possible that this is the line voltage, because if nothing is provided, then we have to assume that this is the line voltage. If it is the line voltage, then what will be the phase voltage? Then the phase voltage will be whatever the line voltage divided by √3. So the phase voltage will be 10 volt. So the RMS of this phase voltage is 10 volt. Since the phase sequence is ABC, then this will be 0 degree, this will be 10 angle minus 120, and this will be 10 angle plus 120. Is it fine, guys? Okay, it is provided. Now the star connected load ZA is given as 10 ohm. Okay, and ZB is given as 20 angle 60. This is given as 20 angle 60. The load, the value of ZC I need to calculate. This ZC I need to calculate, for which the voltage difference across the node N and N prime is 0. This voltage and this voltage are same, because the voltage difference between N and N prime is 0. It is provided in the question. So how to solve this? Assume this as ground. Assume this as ground. If I assume this as ground, it means the voltage at this point is 0 volt. Then what is the voltage at this point? It is given that the voltage difference is 0. It means the voltage at N prime is 0 itself. Okay, this voltage will also be 0 volt. Is it fine, guys? This voltage will also be 0 volt, because it is given in the question. Now what we can do is, if this is 0 and this is also 0, then you can say that this voltage is directly across this, because if this voltage is 0, then the upper point will be 10 angle 0 and this point voltage will also be 10 angle 0. Okay, similarly this voltage will be available here. 10 angle minus 120, and this voltage will be available here. Okay, this is connected. Okay, so you can say that 10 angle 120 will be available here. Is it fine, guys? Now, how to calculate this ZC? What you can do is you can apply KCL. Okay, you can calculate this current, and this current, and that sum should be 0. This way you can calculate the value of ZC. Let's try this. What is this current? This current will be 10 angle 0 divided by 10. 10 angle 0 divided by 10 plus, what is this current? This current is 10 angle minus 120. 10 angle minus 120 divided by the impedance value, that is 20 angle 60. 20 angle 60 plus, what is this current? This current is 10 angle plus 120 divided by ZC. 10 angle plus 120 divided by ZC. This is the total current, and this sum must be 0. This 10 angle 0 is there. Okay, this total sum must be 0. Now from here you can see that this is cancelled, and you can say that 0 is equal to 1 plus 1 by 2 at an angle of minus 180 plus 10 by ZC at an angle of 120. This ZC has some magnitude and some angle. Okay, so angle I have not separated out. That angle is merged in ZC value. Now if you calculate this, minus 180 means it's a negative number. So you can say that 0 is equal to, it is 1 angle 0, it is minus half angle 0. You can write this minus half angle 0 because 180 means negative number. So it's a negative number. So 1 minus half is half angle 0 plus 10 by ZC, and angle of 10 is 120. Is it fine, guys? So take this on the other side. So it will be minus 1 by 2 is equal to 10 angle 120 divided by ZC. From here you can calculate the value of ZC. ZC will be equal to 10 angle 120 divided by minus half. Minus half means 1 by 2 at an angle of 180. Negative number means angle is 180. So you can write it 1 by 2 at an angle of 180. Now it will be 20. So ZC came out to be 20 at an angle of minus 60. Is it fine, guys? 20 at an angle of minus 60. I hope it is clear. Is it fine, guys? Okay, now let's proceed with the next question. I think this was easy peasy. Okay, it is given that this point voltage is 0 volt and this point voltage is also 0 volt. It means if you assume that ground, it means the upper point is 10 angle 0. This point will also be at 10 angle 0. Okay, since this point is 0, so you can say that the voltage difference across this impedance is upper point voltage minus lower point voltage. Similarly, the voltage difference across this and this can be calculated, and the current, you can calculate all the current and take their sum equal to 0. Okay, because there is no return path. So IA plus IB plus IC must be 0. Okay, I applied the KCL. This way you can solve it. I hope you understood it. Sai Vardhan, sir, I am in second year now. Before 2024 gate, how many subjects are better to complete? I think if you are preparing for 2024, 4-5 subjects are enough. You can, if you can prepare 4-5 subjects in this year, that will be a good choice. Okay, now let's proceed with the next question, guys. In this question, it is given that the inductor having Q factor of 60 is connected in series with a capacitor having Q factor of, I don't know what is this number. Please check this, guys. Ground and neutral have 0 voltage. Madhu, wait, let me tell you guys, in this question it is given that this point and this point have the same value. Now at one point I have the choice. Now I can assume reference. If you know nodal, how to apply nodal, so according to that I can assume one reference point. So what I did is I assumed this as a reference point. If I assume this as a reference point, it means this voltage is 0. And it is given that whatever the voltage at this point is, the same voltage will be available here. So if I assume this voltage to be 0, this voltage will also be 0. Okay, that's why I have assumed this point 0. Now if it is 0 and this will also be 0, then the upper point will be 10 volt. So here also you will get the 10 volt. Here you have 10 angle minus 120. So here also you will get the 10 angle minus 120, and here you will get 10 angle plus 120. Now you can calculate the difference, voltage difference across these impedances and apply the KCL. Okay, I hope you understood. Sir, if one impedance is short circuited, we need to calculate load as star or delta. No, it doesn't matter. First of all, you can't sort it. In this situation, you can't sort it. Why? What's the problem? What's the problem? Viswanath and Murli. He's saying if one impedance is sorted, look, if this is sorted, then this point will be 0 volt. This point will also be at 0 volt if it is sorted. But this point is given as 10 angle minus 120. So if somehow you sort it, it means you are sorting this voltage source, and voltage source can never be short circuited. So you can't assume these conditions from nowhere, okay? I mean, it's not your choice. You can't take your choice, okay? Because this is not valid. It is an invalid circuit now. If you sort this impedance, then this voltage source will be short circuited, and this is not possible. A voltage source can never be short circuited, okay? So you can't do that. I hope you understood it. Anyway, let's proceed with the next question. So in this question, an inductor having Q factor of 60 is connected in series with a capacitor having Q factor of 240. Is it correct, guys? Please check this statement. I have doubt with this Q factor. Is it correct? Please check GATE 2022 EE question. Please check from the original source. Is it 240 or some other number is given? Is it 240? Okay. Let's start this question. An inductor having a Q factor of 60. Now, if you look at the practical inductor, then practical inductor can be represented by this. It has some resistance and some inductance. Now, how it came into picture? Let me tell you how to design an inductor. In inductor, you generally what you do is you take a solenoid, you take a cylinder. On the cylinder, you put some turns, no? Then you make the inductor, no? So you can say that the inductor can be represented like the electrical model of this inductor can be represented like this. So it has some resistance. Obviously, you use copper wire, so copper wire has some resistance, and it has some inductance. And the quality factor of this will be omega L by R. Omega L by R. Let's call it R1. Resistance is R1. So the quality factor is omega L by R1. Now I have the capacitor. Now if you have the capacitor, then the practical capacitor can be represented in two ways. One is this way, okay, and one is this way. One is this way. Okay, practical capacitor has some resistance also. Okay, leakage resistance we call it. One is this way. You can represent a practical capacitor like this, or you can represent the practical capacitor like this. Now I'll use this model. Now you'll ask me, sir, why you are using this model? Yeah, that's a good question. Okay, I'll come to that. But if you use this model, then let's call it R2, and this is my C. Now what is the quality factor of this? The quality factor of this is 1 over omega R2C. This is the quality factor we have now. Okay, in this case we have the quality factor like this. But if you use this model, then the quality factor will be, this will be in the numerator. Omega R2C will be in the numerator. Okay, it will not be in the denominator. Okay, so you can say that the quality factor of this circuit will be this. Is it fine, guys? But if you use this model, then this resistance will change, obviously. Okay, and this capacitance value will also be changed. I mean, the impedance should remain same. The impedance between these 2 points should remain same. For now, you just assume that this is my capacitor, practical capacitor. So we have this practical capacitor, and the quality factor of this practical capacitor is this. You should know this, okay? That the quality factor of this branch is this, and the quality factor of this is this. Okay, now what I did is, let's call it Q1 and let's call it Q2. Now what I did is, I connect them in series. If you connect them in series, then the circuit will look like this. R1L, R2C. So it will become a series RLC. LC R1 R2. Is it fine, guys? It will become a series RLC circuit. You can see that. Okay, you can see that. Now you can see that R1 and R2 are in series, so you can take them in series, you can combine them. So it will become a series RLC circuit. R1 plus R2, L and C. Now I need to calculate the quality factor of this circuit. What is the quality factor of this circuit? Tell me guys, what is the quality factor of this circuit? Now the quality factor of this circuit is 1 by R1 plus R2 root L by C. Okay, in series circuit, in series RLC circuit, the quality factor is 1 by R, whatever resistance is. Now the resistance is R1 plus R2 into root of L by C. Is it fine guys? 1 by R root of L by C. This is the quality factor. Now I need to calculate this quality factor. How to calculate this quality factor? This Q1 is provided as 60 and this Q2 is provided as 240. Now from these two values, calculate this R1 and R2. If you calculate R1 from here, then you will get R1 is equal to omega L by 60 and R2 is equal to 240 1 by 240 omega into C. Is it fine guys? So what you can do is you can calculate R1 and R2. I have calculated R1 from here. Omega L by 60 is R1 and 1 by 240 into omega C, that is R2. So put the value of R1 and R2 in this equation and you'll get the overall quality factor. Okay, so the overall quality factor will be 1 over omega L upon 60 plus 1 by 240 omega C into 1 L by C. Now what is this omega? We usually take this omega as resonance frequency, 1 by root LC. Okay, you take this omega as 1 by root LC. So if you take this omega as 1 by root LC, then it will be 1 by, now tell me, if you put omega equal to 1 by root LC, it will become 1 by 60 root of L by C plus, here you have 1 by 240 and put omega equal to 1 by root LC. If you put omega equal to 1 by root LC, then root L will come in the numerator, 1 by root LC. If you take omega equal to 1 by root LC, then root L will come in the numerator and in the denominator you have, okay, is it fine guys? This will be the, if you put the omega, and here in the numerator you have root LC, root L by C. Okay, now take this root LC common, this will be cancelled and the overall quality factor will be 1 over 1 by 60 plus 1 by 240. Is it fine guys? Now you need to calculate this value. Tell me guys, now you need to calculate this value and easily you can calculate it. Tell me what value, what is the value of this quality factor? So you can get the answer as the 240 will be the LCM. If you take the LCM 240, then that will come in the numerator 240 and in the denominator you have 4 plus 1. Okay, so answer is 48. Okay, answer is 48. Now many students think that, sir, why you have not used this? I can use this also, there is no problem. Now if I use this value, obviously this resistance will be different from this. Let's say this is R3 and this capacitance will also be different because this is the equivalent of this, no? So you have to calculate this R3 and C prime and the quality factor is omega R3 C prime. This will be the quality factor. Now if you use this model, this will be the quality factor. If you calculate this R3 in terms of R2 and C prime in terms of R2 and C, then you will get the same value. Okay, it means whether you select this model for capacitor or this model for the capacitor, you'll get the same value. Okay, you'll get the same value. Quality factor will be same. This will be the formula for quality factor. But remember, whenever you use this model, you have to write the quality factor this omega R3 C prime. This is the quality factor. But if you put this R3 value and C prime value in terms of R2 and C, then you'll get the same value. Okay, I don't know how many of you understood this point. That's why it's better to avoid this circuit. No? It's better to avoid this circuit. The circuit by which you can solve it easily, that circuit we call it, that circuit we are going to use it. Okay, so this circuit is easy for us. this circuit, the capacitor equivalent circuit is easy for us because they are connected in series. So if they are connected in series, then it will become series RLC circuit. Okay, I hope you understood it. Madhu, if we take inductor and capacitor Q, if both in parallel, will it get the same? Okay, then you have to check. You can connect them in parallel also. You can connect them in parallel, and then you have to check, because right now what I did is I applied this formula. Okay, I know that in series RLC, because if you connect them in series, you'll get a simple resistance, inductance and capacitance. But in parallel, this will not be like this. This will not be a circuit like this, RLC. This will not be the circuit like this. Then what you have to use it, if you connect them in parallel, then you don't need to use this model and this model, this model and this model. Whenever you are connecting in parallel, then you have to use the parallel equivalent of the inductor. This is the equivalent model of the inductor branch. Okay, we have to use this model, and here we have to use this model. We have to use this model, so that if you connect them in parallel, then this resistance and this resistance can be combined together. Okay, then you have to use this model and this model. Now if you use this model, then the quality factor will be omega RC. This will be the quality factor, and here the quality factor will be different. This will not be the quality factor now. Is it fine? So you have to be careful whether you are connecting them in parallel or in series. If you connect them in series, then we are going to use this model, because this R1 and R2 can be added directly, and we know the quality factor of this and we know the quality factor of this. So if you are going to connect them in series, then total resistance will be added, and then I applied the formula for quality factor. Similarly, if you connect them in parallel, then you use this model and you use this model. Okay, and then you apply the formula for quality factor. The formula for quality factor will be equal to, here it was 1 by R root LC. Here the formula will change. It will be R root C by L. I think the quality factor here is different. In parallel RLC circuit, the quality factor formula is little bit different. Okay, it's opposite, I think. Okay, then you have to put this resistance R as parallel of this resistance and this resistance. This will be this resistance. Now you have to represent R1 R2 divided by R1 plus R2, and we have to put the value of R1 R2 divided by R1 plus R2 in terms of Q1 and Q2, the same way we have done here. Okay, so be careful. I mean, the process is simple. Don't cram anything. Okay, don't cram anything. What you need to do is you just need to think, which model should I use, whether I use this model or the parallel model. Whenever you are going to connect in parallel, use this parallel model, so that this resistance can be combined and you can make one resistance. Whenever you are going to connect them in series, use this model. Okay, and then make the equivalent diagram and write the equivalent Q factor, and then put the value of R1 R2 in terms of Q factor. Calculate this value of R1 R2 in terms of Q factor, and then calculate the overall Q factor. Okay, but remember one point. The point which is important is, whenever this is in series or this is in series, then the quality factor here will be 1 by omega R2C. And in this model, the quality factor is omega RC. It means the quality factor is changing. So you have to be careful. What is the quality factor of this circuit and this circuit? That quality factor you need to use. Okay, I hope you understood it. Let's proceed with the next question. Look at the next question, guys. In the network shown below has a resonance frequency of 150 kilohertz and the bandwidth of 600 hertz. Bandwidth is 600 hertz and the frequency is 150 kilohertz. This is again 2022 question. So resonance frequency is given, bandwidth is given. We need to calculate the Q factor. I think it's easy peasy. Okay, you directly apply the formula and you'll get the Q factor. Q factor is equal to, tell me guys, it's the resonance frequency divided by the bandwidth. Okay, so you can easily calculate the Q factor. I don't want to calculate this. Okay, I think you can easily solve this question. It's just a formula based question. Let's come to the next question. Guys. Now please tell me, in the circuit below, the switch S is closed at t equal to, I think at t equal to 0. Let me check the original file. Okay, the switch S is closed at t equal to, what is the value of t equal to? I think at t equal to 0 it is given. I don't know, because it is missing in the original file also. Okay, please check this value. I think this is the question. In the circuit, the switch S is closed at t equal to 0, the magnitude of steady state voltage. Okay, steady state voltage in volt across 6 ohm resistor. Across this resistance, I need to calculate the steady state voltage. I think it's easy peasy. If you close this switch, then this circuit will start working, and under steady state this capacitor will be open circuited. You know that. It means this branch will stop working. There will be no current in this branch. So the current which will flow the current will flow via this branch only, these two resistances and this resistance. Via these branches, via these three branches, the current will flow. Okay. Now what is the current value? How much current will flow under steady state? So if you take the parallel equivalent of 6 and 3, you'll get 2 ohm. Okay. 6 into 3 divided by 9. Okay. So it will be 2 ohm. So the parallel of this is 2 plus 2, 4 ohm. So it means the current will be 10 divided by 4, that is 2.5 ampere. 2.5 ampere will flow via this this source will supply 2.5 ampere. Now this 2.5 ampere will be divided into two parts. We need to calculate this voltage, the voltage across 6 ohm resistor under steady state. So what is this current, guys? This current will be 2.5. You can apply this current division, na? 2.5 into 3 divided by 9. Okay. So it will be 2.5 divided by 3 ampere. This much of current will flow through 6 ohm. Now what is the voltage here? Current into this resistance. Okay. So 2.5 upon 3 into 6. So you'll get 5 volt. Okay. So the answer is 5 volt. Is it fine, guys? So this way you can solve this. I think this was a very easy question. Now let's proceed with the next question. Look at the next question, guys. Again, this is very good question. The two balanced three-phase load. Now this is for I think for EE only, E and IN, not for EC. So for EC student, you can solve this question, guys. So start solving this question. Okay, start solving this question, because I'll come back to this question, because this question is not for EE student. For EC student, because in EC student, three-phase circuit is not included in your GATE syllabus. So you can ignore this question, but till then you can solve this question. Okay, take the screenshot and start solving this question so that I can so that you can match the answer with me. So for EC student, please solve this question. Okay, read the statement. In the circuit shown below, the magnitude of the voltage V1, in volts across 8 kilo ohm resistor. We need to calculate this V1. Okay, we need to calculate this V1. What is this V1? Okay, so please try to solve this question, EC student. Now let's come back to the original question, the previous question, and then we'll come back to this question. Okay, for EE student and IN student, please careful. To balance three-phase load, there are two loads. One is connected in delta, one connected in star. Both are balanced. Okay, are connected to 10√3 volt. 10√3 is the line voltage, because nothing is provided whether this is phase or line. So it's a line voltage, and also it is given that this is the voltage between R phase and Y phase. So you can say this is line voltage. Okay, so and this is 100√3. This should not be 10, and it should be 100√3, because in the figure it is given as 100√3. Anyway, is connected to 100√3 volt, 3 phase, 50 hertz main supply. Okay, so it is given that this is 100√3. Z1 is given as 18 plus J24. This impedance is given as 18 plus J24. Okay, and Z2 is given as 6 plus J8. 6 plus J8. What I need to calculate is the ammeter reading. Ammeter means line current I need to calculate. What is the line current? I need to calculate the line current. Now how to do that? It's simple, guys. What you need to do is, the inner load is already star connected. So let's make it star only. Na? Let's keep it star only. This is my star load, so I don't disturb it. This is Z1, oh, this is Z2 actually. Z2, Z2 and Z2. Now what I need to do is, better you convert this delta into star. If you convert this delta into star, then the value will be Z1 into Z1 divided by 3 Z1. Okay, so Z1 by 3. So if you connect, it will be Z1 by 3. Now I have converted this delta into star. Okay, Z1 by 3, here also Z1 by 3, and here also you will get Z1 by 3. So there will be 3 impedances, Z1 by, and obviously they are connected in star. Wait a minute, let me draw it at some different position. Okay, so we have Z1 by 3, Z1 by 3 and Z1 by 3. Okay, so this is my star of this delta is converted into star. Is it fine? Now look, this phase is connected here, A phase is connected here, B phase, C phase is connected here, okay, and B phase is connected. I mean this point and this point is connected. So will you say that these are in parallel? Tell me, this Z2 and this Z1 by 3, will they be in parallel? Yes, they will be in parallel. They will be in parallel. How can you say that? How can you say that Z2 and Z1 by 3 will be in parallel? This neutral point and this neutral point are not in parallel. This neutral point and neutral point are only the A phase point, B phase point and C phase point are connected. But the neutral of these two impedances are not connected. So what? There is no problem. The load is balanced and the source is balanced. Whenever the load is balanced and the source is balanced, you can connect their neutral points. You can connect their neutral points. There is no problem. So you can say that Z2 and Z1 by 3 are in parallel. Okay, you can assume that Z2 and Z1 by 3 are in parallel. So take their parallel. Now what is the parallel of Z2 and Z1 by 3? Okay, because Z2 is here, and if you convert it into star, then it will be in parallel with this. Okay, so it will become you can say Z2 in parallel with Z1 by 3. So the impedance will be Z2 into Z1 by 3 divided by Z2 plus Z1 by 3. Is it fine? This is the equivalent impedance for this phase, for this A phase, you can say. So I have replaced the equivalent impedance in star form. Okay, is it fine, guys? This is the equivalent impedance. Now what is the phase voltage? If the line voltage is 100 root 3, then the phase voltage is 100. Okay, now whatever this impedance value is, 100 divided by this equivalent impedance, you will get the current, the line current, and the line current is asked. Is it fine, guys? So this way you can calculate the line current. It's easy peasy. Okay, you need to calculate this equivalent impedance. 100 divided by that equivalent impedance, that will be the current, that will be the ammeter current. Is it fine? Is it fine, guys? Is it fine? Please check it. Let me tell you, if the impedances were not balanced, if the impedances were not balanced, then you can't say that this impedance and this impedance will be in parallel. Okay, if let's say this Z1, 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 they will not be balanced. Okay, let's say this is Z1, this is some Z1 prime, this is Z1 double prime. The impedances are not equal, and if you connect them in star, if you convert them in star, then you can't say that this Z2 and this Z1 by 3 will be in parallel, because since the impedances are not in parallel, you can't say that their neutral have the same voltage. You can't say that this impedance and this impedance will be in parallel. Okay, so be careful this time. You are lucky that these impedances came out to be in these impedances are equal, so the load came out to be balanced. Okay, so whenever the load is balanced, you can say like this. Is it fine, guys? Can I proceed? I think you can solve it now. I think you can solve this this now, because everything I required is the parallel combination. Let me do this. Z1 by 3. What is Z1 by 3? You can divide it by 3, so you'll get 6 plus J8. Okay, this is Z1 by 3. So Z1 by 3 into Z2 divided by Z1 plus Z2. So this equivalent came out to be, let me write this value. This came out to be 3 plus J4. Okay, 3 plus J4. You can check it. This into this divide by this plus this. So 3 plus J4. So this is 3 plus J4. Is it fine? So 100 divided by 3 plus J4. And if you calculate the magnitude, you will get 20. Okay, you will get 20. So the answer is 20. Okay. So this was again easy peasy question. But remember, this question was easy because the load is balanced. In delta or in star, the load is balanced. If let's say this star is unbalanced, then if the star is unbalanced, this, let's say this Z2 and this Z2 and this Z2 will be different. Let's say this is Z2, this is Z2 prime, and this is Z2 double prime. And this delta is balanced, let's say, or unbalanced, whatever. Okay. Let's say this Z1 is, this delta load is balanced. Okay. But this internal star load is unbalanced. Then you can't say that this neutral and this neutral will have the same potential. They will not have the same potential. So if they don't have the same potential, this impedance and this impedance will not be in parallel. You can't assume them in parallel. Okay. Because the upper point is connected, yes, that's correct, but the lower point has different potential. If they have different potential, they can't be connected. Is it fine, guys? So be careful in this question. You are lucky. Okay, in this question you're lucky. Anyway, let's come to the next question. Okay, look at this question, guys. In this question, the circuit shown below, the magnitude of voltage V1, we need to calculate the magnitude of voltage V1. Can you tell me? I think for EC student, those who have solved it, please tell me. Please tell me, guys. EC student, tell me, guys, what is the answer? Have you calculated this? Tell me, everyone. Tell me, have you calculated this question? Okay, let's see. EC student, tell me, everyone. EC student, tell me. Okay, Ravi Shankar is saying 100 volt. Paul, 100 volt. Vishwanathan, 60. Anyone else who have solved it? Let's see, guys. Let's see what is the answer. In the circuit shown below, the magnitude of voltage V1 in volts across 8 kilo ohm resistor is. We need to calculate this voltage. Now, how to calculate? Let's apply nodal. Simple. Assume this as ground. If I assume this as ground, this point will also be at 0 volt. Okay. This point will also be at 0 volt. Now, I can apply the KVL in this loop and KVL in this loop. But problem is, I don't know this current, I don't know the voltage across this current source. So what you can do is you can write V1 as 8 kilo ohm into I, 8000 into I. You can write like this. Okay, V1 is 8000 into I. I think that's correct. Now in this circuit, if you write the KVL, then the KVL will be 75 minus 2000 I minus half V1, that is equal to 0. Is it fine? Now you can replace this I1, replace this I by V1 by 8000. So 75 minus 2000 into I is V1 by 8000. Is it fine, guys? Minus half V1 is equal to 0. So this is cancelled with 4. So you will get 75 is equal to, what is the coefficient of V1? 3 by 4. Is it fine? Is it fine? So this is cancelled with 25. So you'll get V1 as 100. Okay. V1 as 100 volt. Okay. So this was easy question. Anyway, we need to apply the KVL. It was very simple question. Let's come to the next question. The next question is on your screen. If there is no dependent source on right side, can full load will flow? Okay, Madhu is saying, let's say this independent source is absent. If there is no independent source, then you can say that the current in entire circuit will be 0 everywhere. There will be no current anywhere. If there is no independent circuit if there is no independent source in the circuit, then you can say that in every branch the current will be 0. If the current is 0, then the voltage at each point will be same. Now, what is the voltage then? Whatever reference you have selected, that voltage will remain same everywhere. Let's say this 75 is absent. If this 75 is absent, let's say it's sorted here. Okay, then you assume this voltage as 0, so everywhere you will get 0 volt. Okay, everywhere you will get 0. If the reference is selected as 10 volt, let's say someone select the reference as 10 volt, then everywhere you will get 10 volt. and the current will be 0. Is it fine? And the voltage across each element will be 0. Is it fine, guys? So remember this point, okay? If there is no dependent source, okay, you are saying dependent source on the right side, can full load current will flow through the source circuit? Okay, you are saying that if there is no dependent source, there is independent source, okay? If there is independent source and this no dependent source, then what will happen is this current will be, if you apply the KVL, then this will be 75 upon 2000, okay? This will be my I, okay? Once you get this I, you can calculate this V1, it's simple, okay? But because we have dependent sources, then while you're writing the KVL, you'll have to consider this source also, okay? So I think this was easy question. Now let's proceed with the next question. Next question is, in the given circuit, the value of the capacitor that makes I equal to 0. I need to calculate this capacitor so that this current is 0, okay? Tell me guys, how to solve this question? How to solve this question? Obviously, assume that the impedance of this branch become infinite. If the impedance of this branch become infinite, it means it's open circuit here. If it is open circuit, then the current from the source will be 0. Is it fine, guys? Tell me. Is it fine? Now try to calculate the value of C such that this become infinite. Now how it will become infinite? Obviously there are two branches, one branch here, one branch here. If the admittance becomes 0 in parallel branch, obviously the two branches are connected in parallel. If their admittance becomes 0, then their impedance will become infinite, okay? So what I need to do is, I need to make their admittance equal to 0, okay? How to make their admittance equal to 0? What is the admittance of this branch? Admittance of this is 1 upon J5, 1 upon J5 plus, because in parallel we can directly add their admittances. What is the admittance of this branch? Admittance of this branch is 1 upon J5 minus J by omega C. Is it fine, guys? 1 upon the total impedance is J5 plus 1 by J omega C, okay? This is the total impedance now. So I have written in 1 upon so that the admittance can be calculated now. So if I take this J out, this total admittance has to be 0, okay? This total admittance has to be 0. Is it fine, guys? Now from here you can calculate this C. How to calculate? Take this J out now. If I take this J out, then it will be 0 equal to 1 by 5 plus 1 upon 5 minus 1 by omega C. Is it fine? Now what is this omega? Omega is 5000 radian. So put omega equal to 5000 and if you write it, so it will be 1 minus 1 by 5 is equal to 1 upon 5 minus 1 by 5000 into C. I think you can calculate everything from here, okay? Take this on this side, so 1 upon 5000 C minus 5 is equal to 5. Is it fine? So C will be equal to 1 upon 50,000, okay? Please check this calculation. Is it fine, guys? So it's 20 microfarad. Yes, that's correct, okay? So the answer came out to be 20 microfarad. Is it fine, guys? I think it's easy peasy. In 2 lines you can solve this question. I hope you understood it. Let's proceed with the next question. 20 microfarad. Okay, perfect. Let's proceed with the next question, guys. So this is the next question. In this question, what is asked? For the network shown, the equivalent Thevenin voltage and Thevenin impedance seen at the terminal AB. Between these two terminals, I need to calculate Thevenin voltage and Thevenin impedance. Now, you have to be careful. You don't need to calculate both. Because look, Thevenin voltage is given different in each example. In A option it is 50, B option 65, 35 and 10. It means if somehow we can calculate Thevenin voltage correctly, we will get the answer. We don't need to calculate Thevenin resistance because calculation of Thevenin resistance will be a bit difficult. So rather you calculate Thevenin voltage. Okay. Now how to calculate this open circuit voltage? Because that calculation of that part is easy. That's why I'm going to calculate that. And moreover, I'm not going to calculate the Thevenin resistance. Why? Because in 2 option, Thevenin resistance is given as 2 ohm. It means let's say RTH is 2. Then I will not be able to eliminate all the options. Because 2 options has same Thevenin resistance. Is it fine, guys? That's why I'll not waste my time in calculating Thevenin resistance. I'll put my energy in calculating Thevenin voltage, because Thevenin voltage is different in all the 4 examples. So you have to play smart. Now tell me, what is this open circuit voltage? First of all, you calculate, because whatever the current, open circuit voltage I need to calculate. The current will flow like this. I1 will be 5 ampere. If I1 is 5 ampere, this will be 15 volt. Tell me, guys. Okay. Now, if I assume that this is grounded, what is this voltage? This voltage is 5 into 10. 50 volt is there. It means the upper point will be at 50 volt. Okay. If this is 50, this point will be 50 plus 15. It will be 65. Okay. This point is 65. This point will also be at 65. Okay. So answer is Bombay. Is it correct, guys? Okay. So answer is Bombay. Using VTH only, I get the correct answer. I'll not go with RTH. I hope you understood it. Okay. Let's proceed with the next question. Question number 9. In the given circuit, the voltage Vy to be 0. Okay. This voltage is given as 0 volt. Okay. The value of beta should be, where is beta? What is beta? I think this source value is missing. No? What is the dependent source value? Can you check it? Let me check this dependent source value, because I think this is missing. Okay. Can you tell me, guys? Okay. This is missing in the original file also. Tell me, guys, what is this dependent source value? I think this is for GATE 2021. This question is GATE 2021 EE. GATE 2021 EE. Please check this dependent source value. What is this value? Can you tell me this value? Because beta will be in this dependent source, no? Can you check this dependent source? It is given that this value is 0. This voltage is 0. Okay. If I know this dependent source value, then I'll get the beta. Now please check GATE 2021 EE question. What is this dependent source value given? Because there is a typing mistake here. Okay. Please check it and tell me so that I can solve this question. Till then, we can solve the next question. If someone will help me in the chat section, please tell me what is the value of this dependent source so that I can solve it. Okay. Okay. Till then, let's try this question. Again, this question is not for EC student, because this is again 3-phase circuit question. So what I can do is, for EC student, try this question. Okay. EC student, try this question. In this question, it is given that an air core radio frequency transformer as shown has the primary winding and secondary winding. This is a transformer. Okay. It is given to us. The mutual inductance between the winding of the transformer is, we need to calculate this mutual inductance. Okay. We need to calculate the mutual inductance between them. What is the mutual inductance? And okay, I don't know. Okay, it is given at 7.3 peak to peak. This voltage is given at 7.3 peak to peak. Okay, 7.3 peak to peak. Okay, but I think, okay, this voltage is given as 5 volt peak to peak. This is given as 5 volt peak to peak. Now it is given that this is 100 kilohertz. So please try this question. Till then, okay, Sahil is saying this is beta Vx. Beta Vx. Okay. Okay, this is beta Vx. Now we can solve it. Now we can solve this question. Okay, everyone, please try to solve this question. Please try to solve this question. In the given circuit for the voltage, Vy to be 0, Vy is given as 0. The value of beta, I need to calculate the value of beta. What is the value of beta? We need to calculate. It is given that this voltage is 0. Okay. Now, if this is 0 and this voltage is also 0, then I can say that this voltage will be beta Vx. Is it fine? This is 0, this is beta Vx. Now, how much current it will try to send in this direction? It will be beta Vx by 3. Is it fine? Beta Vx by 3. This will be the current in this direction. And here the current is 2 ampere. So the current is coming like this. From this side, current is coming like this. So the net current in this side will be 2 plus beta Vx divided by 3. Is it fine? This is the net current which will flow in this direction. I hope you understood it. Now I can apply the nodal at this point. we know that the current entering from this side is this. This is, now you can assume this side as a current source, and the current source value is this. What you can do is, you can assume this circuit is like this. This is 1 ohm and this is 4 ohm, okay, and here you have 6 volt. Since you know the current from this side, so what you can do is, you can imagine the entire circuit with a current source. You can imagine this entire circuit with a current source, and the current source value is 2 plus beta Vx by 3, and this voltage is given as Vx. Now I can apply the nodal. I can write the nodal equation and I can calculate the beta value. Okay. Now what is the beta value? Let's apply this nodal. The coefficient of Vx, if I write the nodal equation, the coefficient of Vx is 1 by 1 plus 1 by 4 equal to entering current. Entering current is 6 upon 1 from this side plus 2 plus beta Vx by 3. Beta Vx by 3. Is it fine, guys? Beta Vx by 3. Okay. This will be my equation. This will be my equation. Okay. Now, wait a minute. Okay. From here, you get this equation, no? You get this equation Vx. It is 5 by 4. It is 5 by 4 minus beta by 3. Minus beta by 3 is equal to 8. Is it fine? This is the equation we get from here. Using KCL, using nodal, I'll get this equation. Is it fine, guys? So this is one equation. This is one equation. What I did is, I know that this is 0 and this is beta Vx. So from this beta Vx to 0, there will be a current. Beta Vx minus 0 divided by 3. This current will flow, and from here this is 2. So the total current in this branch is 2 plus beta Vx by 3. This is the total current which will flow in this direction. Okay. Now I replace this entire circuit by this current source. I assume that this current is constant, which is coming from this side. So I replace this entire circuit with a current source, and the current source value is 2 plus beta Vx by 3. Okay. And here I have the Vx value, here the 4 volt and 1 ohm and 6. Now I applied nodal. I write the nodal equation in terms of Vx. So I get this equation. Fine. Now I need one more equation. So that we can calculate this beta, because we need to replace this Vx now. How to write this one more equation? It's very simple. This voltage is 0. We know this current. So the voltage across this 2 ohm will be 2 into this current. Okay. So you can say that the voltage across this 2 ohm will be 2 into 2 plus beta Vx by 3. Is it fine, guys? This will be the voltage across this 2 ohm. Now if this is 0 minus this voltage, you'll get Vx. So Vx is equal to minus of this value. Is it fine, guys? 0 minus of this value will be equal to Vx. So from here you can say that Vx is equal to minus 4 minus 2 beta Vx by 3. Is it fine? Now take this 2 beta Vx by 3 on this side. So you'll get Vx into 1 plus 2 beta by 3 is equal to minus 4. I hope you understood it. So there is one more equation we get. Is it fine, guys? You can check. There is one more equation we get from here, and there is one more equation here. Okay. So there are two equations now. Now I can replace this Vx and calculate the value of beta. Okay. Now how to solve it? Let's simplify this. So Vx into, I think calculation is correct. Please check the calculation, guys, because I'm not sure about calculation, but my method will not be wrong. Okay. Check the calculation only. This will be minus 4. Okay. So this way we can calculate Vx. Vx came out to be minus 12 divided by 3 plus 2 beta. You can check this. Okay. So Vx came out to be this value. Now you can use this value and put it here. So it will be minus 12 divided by 3 plus 2 beta into this. If you take the LCM will be 12. Here you will get 15 minus 4 beta is equal to 8. Is it fine? This 12 will be cancelled. Okay. And take this 3 plus 2 beta on this side, and here on the left side you will have 4 beta minus 15. 4 beta minus, because I have taken this minus sign inside now. So 4 beta minus 15 is equal to 8 into 2 beta plus 3. Is it fine, guys? So from here you can calculate the beta value. Tell me, guys, what is beta? What is beta? I hope you understood it. This was again a very nice question. So tell me what is the beta here? So it will be 16 beta minus 2, so 12 beta. So on the right side you will have 16 beta minus 4 beta, that is 12 beta. On the right side you have 12 beta, and on the left side, on this side you have minus 15, on this side you have 24, so 24 will come on this side, it will be minus 15 minus 24. So minus 15 minus 24 is minus 39. Is it correct? Minus 39. Is it correct, guys? So beta came out to be minus 39 by 12. Please check it. Okay, beta came out to be minus 39 upon 12. Please check this value, guys. Please check my calculation whether I have done it correctly or not. Is there any calculation mistake, or is this correct answer? Tell me, guys, because I don't know the answer. I don't know the answer. Even I have not solved these questions prior to this class, okay? Because I know that some teacher come after preparation. I thought that network theory is an easy subject. Why should I prepare for that? Anyway, so I came directly. Please check this value whether this is correct or not. Please check this value. Please check this value whether it is correct or not. I hope that calculation part is correct. Okay. Because if the calculation part is correct, I think then everything is fine. So what I did is first I calculated this current, and then I replaced this entire circuit with a constant current source and apply the nodal, and I have written the nodal equation. Fine. The second thing is, I know this current now, and this voltage is 0, it is provided to us. If this is 0 and this current is known, so 0 minus this drop will be the Vx, okay? So 0 minus this is the voltage, and it will be equal to Vx. So one equation will get from here, and one equation is from nodal. So I simplified it, okay? So try two nodes at Vx and Vy. No, you try, Paul, okay? You try via that method. I'm not going to do that. Why should I try two methods? Why should I try two nodes? Tell me, okay? Because if this is 0, why should I try via two methods? Well, the two equations I need to solve, okay? Two variables I need to solve. Remember, not only two, actually then the variable will be 3. If you are solving Vx, Vy and beta also, so there are 3 variables. So you are going to solve 3 variable equation. That will be very lengthy, okay? Is it fine, guys? So that's why I put this value 0, okay? We'll get Vx value. No, let me tell you again. What I'm doing is I'm putting this 0 because I don't want to create extra variable. I want to minimize the variable. That's why I'm not taking this Vy. You have to be don't try to increase the variable. Don't try to increase the variable, okay? Try to minimize the variable so that the equation will be less and you can solve them easily, okay? I hope you understood this point. You can try with Vx, Vy and beta, there is no problem, but that will be more time consuming, okay? Let's proceed with this question, guys. But let me tell you, for EC student, please try this question because this is not for ECE. Please try this question, guys. Please try this question. In this question, please check the original question because I have doubt in this question because I think there is some term which is missing in this question. Please check this, okay? Please check this. This is GATE, let me tell you, GATE 2020. Wait a minute, let me check which year this question was asked. Yeah, GATE 2021, okay? GATE 2021. GATE 2021 EE. Please check this question. Please check the statement. Okay. First calculation incorrect. Arnab is saying first calculation incorrect. Which calculation is incorrect? Tell me. The coefficient of Vx is 1 by 1 plus 1 by 4 equal to entering current 6 by 1. That is correct. Plus this entering current 2 plus this. So I think this is correct. So here you will get 5 by 4 minus beta by 3, that is 8. I think this is correct, Arnab. Please check your calculation. I think I have done it correctly, okay? Please check your calculation, Arnab, okay? I have done it correctly. Anyway, let's proceed, guys. Yeah, please check this question. This is GATE 2021 EE. Is there any correction in the question, or I think the statement is correct or not? Please check it and try to solve this question, guys. Try to think, the EC student, try to think this question. In the meantime, I'm going to solve this question. Okay, look at this question, guys. A three-phase balanced voltage is applied. A three-phase balanced voltage is applied to the load shown. We have this load, and on this load a three-phase balanced voltage is applied. The phase sequence is RYB. Okay, the ratio of IB upon IR. Okay, IB upon IR is asked. This is IB, this is IR. We need to calculate this ratio. Okay, how to calculate? Look, let's say here the voltage is VR, VY and VB. Okay, let's assume that VR is V angle 0. So this will be V angle minus 120 and this will be V angle plus 120. Is it fine? Because the sequence is RYB. Okay, so R is 0 degree, Y is minus 20 and then B is plus 120. Is it fine? So this is connected directly here. This is connected directly here. Now tell me, it means this point voltage is V angle 120. This is V angle 120. Now if it is V angle 120, then this will be V angle 0. Now what is the phase, what is the voltage difference across it? The voltage difference across it is V angle 0 minus V angle 120. Okay, V angle 0 minus V angle 120. So the resultant will be root 3 V angle minus 30. Okay, V angle 0 minus V angle 120 is root 3 V angle minus 30. Divide by this impedance minus J10. This will be my IR. This will be my IR. Is it fine, guys? So we have calculated IR. Now we need to calculate IB. How to calculate this current? This current is, okay, value of beta, that question, sir, and mention which year. Value of beta, that question, sir, and mention which year and branch. Which question you are asking? This question? This could GATE 2021 EE Ravi Shankar. No, I'm not asking about this question. I think this question is already provided. Someone told me that this is beta Vx. So we have already solved, na? By assuming this as beta Vx, we have already solved. Okay, we have already solved that. The answer came out to be minus 3.25. Okay, I think this is the correct answer, minus 3.25. Okay, Ravi Shankar is getting minus 2. Okay, then check your calculation. I think my calculation is correct. Okay, check your calculation. Okay, check your calculation. Okay, please check this question. Please check this question, whether this statement is correct or not. Please check this question. In the meantime, we can solve this question. So I told you this voltage is given to us. This is V angle 0, this is V angle 120, this is V angle minus 120. Since it is directly sorted here, so you can say that this neutral point will have V angle 120. Now what is the voltage difference across this capacitor? So that I can calculate this IR. So the voltage difference across this capacitor is V angle 0 minus V angle 120. Okay, so it will be root 3 angle minus 30. Divide by minus J10 is IR. Okay, so we have calculated this IR. Now I need to calculate the magnitude. So the magnitude of IR is root 3 V upon 10. Root 3 V upon 10. Okay, so this way we have calculated IR, magnitude of IR. Now I need to calculate magnitude of IB. How to calculate magnitude of IB? It's simple. If you apply the KCL here, so you can say that IR plus IY plus IB equal to 0. IR plus IY plus IB equal to 0. You can see that because the entering current must be 0. Total, because there is no leaving current. Na? So total entering current must be equal to leaving current. Leaving current is 0. So this must be 0. I applied KCL. So IB must be equal to, what is IB? IB must be equal to minus of IR plus IY. We have calculated IR. Now what is IY? IY will be equal to, you know, this voltage and this voltage. This voltage is V angle minus 120. So this minus this I need to do. V angle minus 120 minus of this voltage. So it will be root 3 V at an angle of minus 90. Please check it. This voltage minus this voltage. I think the resultant is root 3 V angle minus 90. Divide by J10. Okay. Divide by J10. Is it fine? Please check it. Please check it. So this will be my IY. Please check it, guys. This voltage minus this voltage. So V angle minus 120 minus of V angle plus 120. So it will be root 3 V at an angle of minus 90. Divide by this impedance. Impedance is J10. So you will get IY. So IY is equal to root 3 V divided by 10. Root 3 V divided by 10 at an angle of minus 90 and further minus 90. So minus 180. Minus 180. This is IY. Okay. This is IR. Let me write this IR also. No? IR is root 3 V upon 10 and angle is minus 30 minus this 90 will come, minus 90 will come in the numerator, so it will become plus 60. Is it fine? Okay. This is my IR, this is my IY. Now what I need to do is I need to add them and take minus sign here so that we can calculate IB. So IB will be equal to, because IB is required, na? IB upon IR is asked. So IB is equal to minus of sum of these two values. Root 3 V by 10 I have taken common. Okay, root 3 V by 10 I have taken common, and this is 1 angle 60 plus 1 angle 180. 1 angle minus 180 or 180, whatever. Okay, so this is my IB. Now please check this calculation. Please tell me what is this number, this 1 angle 60 plus 1 angle minus 180. What is this? Please tell me what is this, so that we can calculate the magnitude of IB. Okay, tell me what is the sum of these two values? Can you calculate? 1 angle 60 plus 1 angle minus 180. Okay, tell me what is IB. Then we will calculate the magnitude of that and take the ratio. Okay, I'm not sure whether this ratio is 1 or not. I don't think so that this ratio came out to be 1. No sir. Okay, please check this value. So this value came out to be, let me tell you. Wait a minute, I think everything is fine. Please check the calculation, guys. Please check the calculation. This minus this, I think this is correct. Please check the calculation. I think everything is fine. Do this sum now. Do this sum. IB is equal to root 3 V upon 10 and minus sign, and this sum is 1 angle 60. Yeah, it's 1 angle 120. Okay, is it correct? 1 angle 120. Is it correct, guys? Tell me. This sum is 1 angle 120. Is it correct? Weber Moria is saying this sum is 1 angle 120. Please check in the calculator. I don't have the calculator. Let me check. Let me see if I have the calculator or not. I think I have the calculator. Okay, so congratulations. I have the calculator, so I can solve it. That is 1 angle 60. 1 angle. Wait a minute. What is the problem? Wait a minute, guys. Yeah, 1 angle. I think it's not working. Why it's not working? Where 1 angle, yes, now it's working. 1 angle 60 minus 1. So you will get a 1 angle 120. That's perfect. Yes, it's 1 angle 120. Now what is the magnitude of this? The magnitude of IB, is root 3 V by 10. Root 3 V by 10. Okay. So both the magnitude came out to be same. So this ratio is 1. Okay. This ratio is 1. This was simple question. Anyway, so we have solved it. Now let's come to the next question. This question, please verify this question. Tell me, guys, from GATE 2021 EE, please verify this question. Is it correct or not? Is this question correct or not? Tell me, everyone, is this question correct or not? If it is correct, then we can solve it. Okay, I think this is correct, by the way. Let's try to solve this question. It is given that this voltage is 5 volt peak to peak. 5 volt peak to peak. Now, using this voltage, we can calculate this current. What is this current? Can you tell me? The current is 5 divided by 2. This is the peak value. Because 5 is peak to peak, na? 5 is peak to peak. So the peak value is 5 by 2. We can call it VM, maximum voltage across this. 2.5. Okay, so the current will be 2.5. Let's call it sinusoidal sine wave, sine of omega t. This is the voltage across it. Okay, 2.5 sine of omega t divided by 22. This is the current here. Is it fine? And this current will flow through the coil. This current will flow through the coil. Is it fine? Is it fine? Okay, this current will flow through the coil. Now, because of this current, here the voltage is induced, and that voltage we call it M di by dt, because only the mutual inductance will participate, because this coil is open circuited. So only the because of this mutual inductance you will get the voltage here, that is M di by dt, and the peak value of this voltage is 7.3 divided by 2. Now let me write this, j omega m into Im sin omega t. This is the peak value of this voltage. This is the peak. So this is the peak value of this voltage. Is it fine, guys? J omega m d by dt is replaced with j omega m into Im. Replace this j also, na? So omega m into Im is the peak voltage. Is the peak voltage here, and that is 7.3 divided by 2. Is it fine, guys? Is it fine? Is it fine? You can check from here. You calculated the voltage. The voltage here is the 2.5 max value. Okay, so the maximum voltage across this resistance is 2.5 divided by 22 is the current. So you'll get the maximum value of the current, 2.5 divided by 22. Okay, this is the and let's assume that this is sinusoidal current. Okay, so I put sine of omega t here. So 2.5 upon 22 sine of omega t. This current will flow in this circuit. So the current is sinusoidal. Now because of this current, you'll have an induced voltage here because of this mutual inductance. So the induced voltage here will be M di by dt. It means this will not be sine. Okay, this will be cos. This will be cos. Okay, so whatever. I mean, I'm not interested in sine or cos. I'm interested in maximum value. I'm interested in maximum value. So d by dt is replaced with j omega m into whatever the maximum value of the current is. Multiply with it. So j omega m into Im. This is the maximum voltage across this coil, and the maximum voltage across this coil is 7.3 by 2. Now what is the maximum value of Im? Im has the maximum value 2.5 divided by 22. Omega is 2 pi f. So you can put the value, no? So 2 pi into f. F is 100 into 10 to the power 3. So 10 to the power 5 into m into peak value of current. Peak value of current is 2.5 divided by 22. Okay, and that is equal to 7.3 by 2. Is it correct? Tell me, guys. Is it correct? Now calculate the value of m. Tell me what is the value of m in microhenry. In microhenry, we need to calculate this value of m. So m will be equal to 2.5 divided by 7.3 by 2. Okay, so 7.3 by 2, this value, and take the entire term in the denominator. So it will be 22 divided by 2.5. This 22 will go in the numerator, 2.5 in the denominator. Okay, and 1 upon 2 pi into 10 to the power 5. 2 pi into 10 to the power 5. Tell me, guys, is it correct? Now tell me, what is this value? M. How much microhenry? Tell me, guys, what is this value? How much microhenry you'll get? Tell me, everyone. Please do the calculation. Please solve it. 51.10. Ravi is saying. So I believe your correction is correct. I don't know. Please check the answer. Okay. So this is the mutual inductance value. Okay. So I hope this is correct. Now let's come to the next question. Can I proceed, guys? Tell me. I think this correction is correct. Tell me, please verify. Is this correct or you are getting different answer? 51.1. Okay, that's fine. Thank you. Thank you. Let's proceed with the next question. So the next question is, in the given circuit, for maximum power to be delivered to RL, okay, we want to deliver the maximum power to RL. Its value should be, what is the value of RL so that the maximum power can be delivered to RL? Tell me, this is the question on maximum power transfer theorem. So I don't need to solve this because I know that the maximum for maximum power transfer, RL must be equal to mode of ZTH. Okay, so what I need to do is I need to calculate Thevenin impedance between these two terminals. Okay, now how to calculate ZTH? Sort it and calculate the Thevenin equivalent of this network. What is the Thevenin equivalent of this network? This resistance in parallel with this reactance. What is this reactance? Can you calculate me? Can you calculate for me? That will be the ZTH, and mode of ZTH will be RL. Okay, now let's calculate the Thevenin impedance. So the impedance for this inductor is J omega L. J omega is 1000, L is 4 millihenry. So the milli is cancelled with this, so J4. So this impedance is J4. Now what is this impedance? It will be minus J by omega. Omega is 10 to the power 3. C is half into 10 to the power minus 3. Okay, this is cancelled, so you'll get minus J2. Okay, so this reactance is minus J2, this is J4. So the total reactance of this path is J2. So you have 2 ohm in parallel with J2. Okay, we need to calculate the Thevenin equivalent, the Thevenin impedance of this circuit. I mean, you can take the parallel. So 2 into J2 divide by 2 plus J2 and take the magnitude. This is my RL. Okay guys, so it will be 4 divided by 2 root 2. The magnitude of numerator will be 4 and the denominator is 2 root 2. So this is cancelled, so you'll get root 2. So the answer is root 2. It's simple. Okay, so this question was simple. Anyway, let's proceed with the next question. Now the input impedance for the network shown. I need to calculate this input impedance. How to calculate this input impedance? Do it guys. Tell me, what should I do? How to calculate the input impedance? Now what you can do is you can replace this network by its T equivalent. Okay, so you can make the circuit like this. 4, you can replace this by its T equivalent. Okay, 5, here you have 1, here you have L1 minus M, so it will be 5, and L2 minus M, it will be 3. Is it correct guys? Tell me. Sir, please mention which branch. I think this is for EE. Okay, this is for EE and gate. Let me check. This question is for gate 2021. Yes, EE gate 2021. I'm solving for EE branch. Tomorrow I have one more session for EC branch. Okay, I'll take EE and EC both. So today I'm solving for EE branch. In the next session I'll solve for EC branch. Okay, tomorrow also I have one more session, so I'm going to take that session also. But anyway, let's try to solve this question. So I need to calculate Zin in Laplace domain. So what I did is I replaced this coupled coil with its T equivalent. Okay, now what is the T equivalent value? Tell me guys, how to replace this T equivalent? L1 minus M, L2 minus M, and here you should replace with M. Okay, now you can write them in Laplace domain. So it is S, it is also S, it is also S. Now I need to calculate Z in S. Okay, the input impedance I need to calculate. Is it fine guys? Ajay Kumar, good evening sir. Sir, आपने गवर्नमेंट जॉब छोड़कर टीचिंग ज्वाइन करना क्यों सही समझा? नहीं, मैंने गवर्नमेंट जॉब छोड़ी नहीं अजय कुमार, मैंने गवर्नमेंट जॉब कभी ज्वाइन ही नहीं किया. मैं गवर्नमेंट जॉब करना ही नहीं चाहता था, बिकॉज आई डोंट वांट टू बी गवर्नमेंट एम्प्लॉय. ओके, मुझे मोदी जी नहीं करना है. समझे आप मेरा पॉइंट? तो गवर्नमेंट जॉब नहीं करना था मुझे. इट्स माय चॉइस, बिकॉज आई एम ए टीचर बाय चॉइस. आई वांटेड टू टीच फ्रॉम द डे वन, फ्रॉम माय इंजीनियरिंग, फ्रॉम माय स्टार्ट ऑफ माय इंजीनियरिंग. सो फर्स्ट ईयर से ही मेरा क्लियर था दैट आई हैव टू बी ए टीचर. ओके, दैट्स व्हाई. सो मैंने कभी गवर्नमेंट जॉब नहीं किया. एनीवे, सो इनपुट Z in S कैसे निकालेंगे? लेट मी टेल यू. व्हाट यू कैन डू इज टेक 5 and 3S in series, and then it will be in parallel with this S, and then you can connect them in series with 4 and 5S. So it will be 4 plus 5S plus the parallel of this S into 3S plus 5 divided by S plus 3S plus 5. So the denominator of the entire term should be 4S plus 4. 4S plus 4. So 4S plus 4 is Nowhere. It should be 4s plus 4, na? It should not be 4s plus 5. Please check it, guys. Please check it. 4, that is L1 minus M, L2 minus M. Here it should be 5. I think this is correct. So it should be 5. It should be 5. Wait a minute, I made a mistake here. Yes, it should be 5. So tell me, the denominator will be 4s plus 5. Now, two options have 4s plus 5. Either B is correct or D is correct. You can eliminate these two options now. Okay. Now, what you can do is you can simplify this and you can calculate this value. So, the denominator is 4s plus 5. And what is the numerator value? What you can do is you just calculate this coefficient, no? S square coefficient. So here the coefficient, here you have 5s plus 4 into 4s plus 5 plus 3s plus 5 into s. Now calculate the s square coefficient. 20s square here and 3s square here. So you will have 23s square. Answer is Bombay. Okay. Answer is Bombay. Is it correct, guys? Is it correct? Chinmay is saying V is equal to L di by dt. Yes, V is equal to L di by dt if there is an inductance. Okay, if there is a pure inductance, then we call it V is equal to L di by dt. Okay, but here the voltage will appear due to mutual inductance. Okay, the voltage will appear due to mutual inductance. That's why I have written M di by dt. Okay, not L di by dt. Okay, let's come to this question, guys. So I told you how to solve this, how to check what is the correct answer. B is correct. No need to simplify the entire process. No, don't waste time. Okay, try to solve the main things. Okay, and then you will get the answer, because the s square term is 23 here and 25 here, so it will tell us the answer. That's why I have only checked the s square coefficient. Okay, so I hope you understood this point. Let's come to the next. So in this question, the waveform shown in solid line is obtained by clipping a full wave rectifier sinusoid. The ratio of RMS value of the full wave rectified waveform to the RMS value of the clipped waveform. Okay, I need to calculate the RMS value of the, because RMS value of the full wave rectified is clearly known to us now. If this peak value is Vm, then the RMS value of the rectified wave is Vm by root 2. That's for sure. It is for the RMS value of the rectified sine wave. If the sine wave is rectified, then this will be the RMS value. If it is fully rectified, okay, if there is no clipping, then you can say that the RMS value of the rectified wave is Vm by root 2. Now I need to calculate RMS value of this wave. RMS value of this wave. How to calculate the RMS value of this wave? So it's very simple. Look, the period is pi. But what can I do is, we know that this is symmetric about pi by 2. So better you make it simple. How to make it simple? How to make it simple? This is 3 pi by 4. 3 pi by 4. Is it 3 pi? No, it cannot be 3 pi. It should be pi by 4. This point is pi by 4. And this point is pi by 2. Okay. This point is pi by 2. Is it fine? Now what I did is, about this point, we know that about this point, this quarter period and this half period and this half period are same, na? So I flipped it. If you flip it, you will get the same. Okay, and then again this wave up to this point. Do you know this method? What is the advantage of this method? What is the advantage of this method? What is the advantage of what is the advantage of flipping this half? The advantage is the period is small now. Okay, now it's easy to calculate the RMS value. Tell me the RMS value now. The period is pi by 2, so the RMS value is root of 1 over pi by 2. So the 2 will come in the numerator. From 0 to pi by 4, what is this wave? This wave is Vm sin omega t. This is the part of sin omega t. So Vm sin omega t from 0 to pi by 4, not pi by 2. From 0 to pi by 4, Vm sin omega t, and take the square of it, d omega t, plus from pi by 4 to pi by 2, 1 by root 2 of Vm. 0.707 is 1 by root 2 of Vm. Take square of it, d omega t. Okay, this is my RMS value. This is my RMS value of this signal. So if I take period as pi, then I have to integrate in 3 parts, from 0 to pi by 4, and then from pi by 4 to 3 pi by 4, and then 3 pi by 4 to pi. Okay, it'll be more difficult for me to solve. That's why I flipped this part such that the period can be reduced, and via flipping, RMS will not change. Okay, remember this point. If you flip the part, if you flip some part of the way, RMS will not change. Okay, so you have to be smart. Okay, is it fine, guys? Is it fine? So this way we can calculate the RMS value. Please calculate this value, and the RMS of the full wave rectified is Vm by root 2. Now you can find this value also and take the ratio. Now it's your part to solve it. Now it's your part. Please try to solve this part and then you can calculate. I don't want to do the calculation because it's easy now. Okay, let's proceed with the next question. Let's proceed with the next question, guys. This is the next question, question number 15. In the circuit, switch S is in the closed position for very long time. Switch S is closed for very long time. Okay, if the switch S is open at t equal to 0, then ILT for t greater than 0. Okay, look, the S was closed for long time. S was closed for long time. If S is closed for long time, then it is sorted here, and you can see that I suppose this is larger. I don't know which one is larger. This is small. Okay, this is larger. This means this is higher voltage, this is lower voltage. Okay, so we have 30 volt here, and this is sorted first, and this was sorted for long time. Now tell me, how much current was flowing through this inductor? How much current was flowing through this inductor? So since it was sorted, this source will provide the current only in this path. Okay, and this source will provide the current via this path. Okay, and it is sorted. Now tell me, if it is sorted, how much current will flow? 10 divided by 1. So the current is 10 ampere. The inductor current is 10 ampere, that's for sure. Is it fine? So the inductor current is 10 ampere, and since it is sorted here, this source will not participate in this current. This source will participate only in this current. Is it fine, guys? Tell me everyone, is it correct? Is it correct? Because this is sorted. If this is 0, this is also 0. So you can say that this 30 volt is entirely across this 4 ohm. So you can say that this current will be 30 by 4, that is 7.5. Okay, 7.5. Is it fine? This current was 7.5 and it is flowing like this, and only 10 volt is responsible for this current. You can sort it, you can apply the KVL in this path, you can sort this inductor, and you will get this current as 10 ampere. So under steady state, up to 0 time, inductor was sorted, so this current was 10 ampere. Now at t equal to 0, what you have done is you have opened this switch. If you have opened this switch, obviously this circuit will come into picture. Now this circuit come into picture. Now the initial current is 10 ampere. Initial current is 10 ampere. I0 is 10 ampere. Now what is the steady state current now? What is the steady state current now? Tell me, what is the steady state current? Now this is open. Now this is open. Now tell me, if you go via this path, then in this path the total voltage is 10 plus 30, that is 40 volt. Now the total voltage is 40 volt, and under steady state again it is sorted. Now tell me how much current will flow? 40 divided by the total resistance, that is 5. So it will be 8 ampere. So under steady state the current will be 8 ampere. Fine. Initially the switch was closed for long time. If the switch is closed for long time, then this current is 10 ampere. So at 0 plus it will remain as 10 ampere because inductor will try to maintain this current. And after opening this switch for long time, after long time, this current will become 8 ampere, because now if this part is open, so this circuit will work now, and in this circuit again it will be sorted after long time, again it will be sorted, and the total voltage is 40 divided by 5 ohm, that is 8 ampere. So in which option you will get this answer? Initial current as 10 and steady state current as 8. Is it fine? So answer is Bombay. Is it correct, guys? So this was very simple question. I hope you understood it. Okay, let's move to the next question. In this question, the current in ammeter A2, and A3 are in A2 it is given as 1 angle 10. Excuse me guys. So the current in ammeter A2 is 1 angle 10 and A3 is 1 angle 70. Okay, is given like this. The reading of the ammeter A1. Okay, I think it's easy peasy. I don't know why they given this question. It's a JE level question. 1 angle 10 plus 1 angle 70 you can add and you will get this current. Okay, so I don't want to solve this question. It's very easy. Let's proceed with the next question. In the next question, the Thevenin equivalent voltage is asked. VTH is asked. So what you can do is you can apply nodal. Direct nodal is enough. This is 0. Let's call it VA. Okay, whatever this VA is, add 10 volt to it because 5 ampere will flow in this direction. So this will be 10 volt. So VA plus 10, you will get the voltage here. That same voltage will appear here. Is it fine? So what is this VA? Let's calculate VA. Apply nodal. Write the direct nodal equation. The coefficient of VA is 1 by 3. 1 by 3 only. Wait a minute. This VA is 4. Directly you can say it's 4. Okay. This VA is 4 because if it is 0, this voltage source is connected directly. Na? So this voltage is 4 volt. And we know that this 5 ampere will flow via this path. So this will be 10 volt. Now if it is 4 volt and this is 10, this voltage will be 14 volt. Fine. If it is 14, this point will also be at 14 volt. So answer is 14. VTH is 14. Is it fine guys? This is again easy peasy question. You can check it. Can I proceed? Can I proceed everyone? Tell me. Let's proceed with the next question. Question number 18. Look at this. A resistor and capacitor are connected in series. Okay. There is a resistor and there is a capacitor which are connected in series. Okay. Series to a 10 volt DC supply through a switch. Okay. We have a switch and 10 volt DC supply. We have a 10 volt DC supply and a switch. Okay. A resistor and capacitor connected in series to a 10 volt DC supply through a switch closed at t equal to 0. Okay. The switch is closed at t equal to 0 and the capacitor voltage is found to cross 0 volt at 0.4 tau. Okay. This capacitor voltage is 0 VCT. Call it VCT. So it is 0 at t equal to 0.4 tau. It means initially it was not 0. Initially it was some negative value. Initially it was charged with opposite polarity, and now if you close the switch, it will keep on charging with this polarity, and first it will come to, initially it was some negative volt, and then it will go like this. At this 0.4 tau, 0.4 tau, it will come to 0 volt. Okay, this capacitor will come to 0 volt. Now it is saying that the absolute value of percentage change required in the initial capacitor voltage if zero crossing has to happen at 0.2 tau. Okay, you want that the 0 volt should come at 0.2 tau. It means you don't want to come, you don't want to take that initial voltage is such that the 0 came out to be at 0.4 tau. You don't want that. You want that this 0 crossing should be at 0.2 tau. Okay, the 0 crossing, you want it should be at 0.2 tau. Now tell me, what is this initial voltage? We call it VC0, we call it VC0, and this is 0 prime, let's say. So in the first case, let's say the initial voltage is VC0. After 0.4 tau, it crosses the 0 point. Here, you want that it should cross the 0 point at 0.2 tau. So what is this initial voltage? And we need to calculate the percentage change. We need to calculate the percentage change. What is the percentage change? How much change I need to take so that the 0 crossing came out to be at 0.2 tau? So I think it's simple. Let's say that this is the initial voltage VC0. In the first case, initial voltage is VC0. What is the steady state voltage, guys? If this circuit will work, the steady state voltage is 10. Okay. Now the equation is VC infinity plus VC0 minus VC infinity e to the power minus t by tau. Okay. And we know that if t is equal to 0.4 tau, this will be 0. So put it 0 put it 0, Vc 0 minus 10 e to the power, put t equal to 0.4 tau. So this will be minus 0.4. Is it fine, guys? From here you can calculate Vc0. Okay, so Vc0 will be equal to, what is Vc0? Take this 10 on this side, so it will be minus 10, and take this e, so it will be 10 e to the power 0.4. okay, 10 e to the power 0.4 with the negative sign plus 10. Is it fine, guys? This is my Vc0. okay, this is my Vc0. Please check it. Okay, please check whether my calculation is correct or not. This is minus 10. okay, and this will go in the denominator, so in the numerator you have the positive sign. I think this is correct. Okay, let me check this value. Let me check this value, Vc0. So this Vc0 came out to be Vc infinity plus Vc0 minus, I think this is correct. So let me check this value. This is came out to be 0.4. Yes, this came out to be minus 4.992. okay, minus 4.92. okay, so this initial value came out to be minus 4.92. now what is this initial value? If you want that zero crossing should take place at 0.2 tau, okay, if you want that the zero crossing should take place at 0.2 tau, then what should be this initial voltage? Equation will remain same. Now in place of this 0.4 you put 0.2. okay, if you put 0.2 here, then the initial voltage will be, is it fine, guys? Then the initial voltage is minus 2.21. this will be minus 2.21. okay, it means if the initial voltage is minus 2.21, then the zero crossing will come after 0.2 tau, and if the initial voltage is minus 4.92, then the zero crossing will come at 0.4 tau. Now we need to calculate the percentage change. okay, so the percentage change is simple, na? Tell me, what is the percentage change? Initially it was this, now it is this. So what is the difference? So you can calculate the difference. okay, so 4.92 minus 2.21. okay, so this is 2.71. so the percentage change is so the difference is 2.71. how much percent this voltage is with respect to the previous one? Tell me. 4.92. okay, this value, how much percent is this? So divide by 4.92 into 100. okay, is it fine, guys? So you can say that it is 55%. okay, so this way you can solve it. The absolute value of the percentage change required in the initial capacitor voltage if the zero crossing has to happen at 0.2. you want that the zero crossing should be at 0.2 tau. So you need to decrease this. You need to, you can say the initial voltage, if you want zero crossing at 0.4 tau, the initial voltage should be minus 4.92. if you want the zero crossing to be at 0.2 tau, the initial voltage should be at minus 2.21. now what is the percentage change? It's 55% change. okay, is it fine, guys? Let's proceed with the next question. okay, look at this question now. A benchtop DC power supply acts as an ideal 4 ampere current source as long as its terminal voltage is below 10 volt. okay, this is again very good question, guys. okay, sir, how much IITs charge for MTech through GATE? I think the tuition fee for IITs is like 32,000 or 33,000. I don't know, but you can check it on the Google. You'll find the answer. okay, you can check it on Google. There are so many students who have put this answer, so they will tell you. Or in Telegram group, if you have joined some Telegram group, you can ask this question in the Telegram group. There will be many students who have joined IITs and they are paying that fee, so they will tell you the exact scenario. Anyway, let's come to the question. A benchtop DC power supply acts as an ideal 4 ampere current source as long as its terminal voltage is below 10. okay, so we have is power supply, DC power supply, and it will act as a current source. It will act as a current source, 4 ampere current source. It will act as a current source as long as its terminal voltage, this V, as long as this V is less than 10. okay, it will act like a constant current source. okay, so if I plot the wave, you can say that if the V is less than 10, it will act like a constant current source, 4 ampere current source. If this V is less than 10, okay, this current will remain constant at 4 ampere. Fine. Beyond this point, it begins to behave as an ideal 10 volt source if all load currents going down to 0 ampere. Now, after this point, if this current is decreased, let's say, if the current is decreased because I am decreasing the load, let's say, if the load is decreased, it means the current is decreasing, then this will act like a voltage source of 10 volt. This will act like a voltage source of 10 volt. It means the voltage is not going beyond this 10 volt. If you are decreasing the current from 4 ampere, if you are decreasing the current, it will act like a 10 volt voltage source. Okay, it is saying like this. Now, we connect it to an ideal rheostat. When we connect it to an ideal rheostat, find the load resistance value at which the maximum power is transferred and the corresponding load voltage and current. He is saying that I am connected a rheostat here. What is the value of this resistance? What is the value of the resistance? Okay, we need to connect a resistance, a rheostat here. We need to calculate the resistance value so that the maximum power is transferred to that and the corresponding value of V and I. Okay. Now tell me, if I connect a rheostat here, what should be the resistance so that the maximum power is transferred? During this range, we know that if the voltage is, let's say, 0 to 10, then we provide a constant current. This will provide a constant current. And if the current is below 4 ampere, then this voltage will remain at 10. So this is the characteristic. Now in this characteristic, can you tell me at what point you have V into I maximum? Obviously at this point. At this point you have maximum V into I. Okay. So the power will be maximum at this point and it will be 40 watt. Okay. It will be 40 watt. So at this point the voltage is 10 and current is 4 ampere. So resistance is 2.5. Okay. Resistance is 2.5. Current is 4 ampere and voltage is 10 volt. Okay. I hope you understood it. Ravi Teja, they are asking for percentage change. So should we not find difference between voltage and then divide? I have done the same, Ravi Teja. We found the difference in the voltage. Difference in the voltage is 4.92 minus 2.21. That is the difference. And then I calculated that difference with respect to this value. How much percent that difference is with this value? Okay. What is this difference? How much percent is this difference with this first value, initial value, which we have taken this was the initial first case value, na? With respect to that, how much value is this change? Okay, how much percent this change is? So it's 55% change. Okay, Ravi Teja. Okay, so in this question the answer is Agra. Okay, because I told you this is the characteristic we have, and at this point you can see that the product is maximum. V into I is maximum at this point, because if you take this point, let's say at this point current is 4 but voltage is less than 10. At this point again current is 4, voltage is less than 10. At this point voltage is 10 but current is less than 4. But at this point you can say that voltage is 10 and current is also 4, maximum. So the product will be maximum. So you can say that this is the point at which the maximum power can be transferred. At this point voltage is 10, current is 4, so resistance is 2.5. Okay, this way you can solve it. Okay, let's come to the next question. Question number 20. Now tell me about question number 20. The current I flowing in the circuit shown below in amperes. I need to calculate this current. Now how to calculate this current? Apply nodal, direct nodal. Do you know how to write the direct nodal equation? It will save your time. Okay, this is 0, this is VA. Let me write the direct nodal equation. The coefficient of VA will be, tell me guys, 1 by 2 plus 1 by 3 is equal to entering current. Entering current is 10 from this side plus 2 plus 5I upon 3. 5I upon 3. Is it fine? This is the nodal equation. Now what is I? I is equal to 20 minus VA by 3. So you can put this value of I here. So this equation will be VA 1 by 2 plus 1 by 3 is equal to 12 plus 5 by 3 into I, and I value is 20 minus VA by 3. Okay. Now take this VA coefficient on this side. So the coefficient of VA is 1 by 2 plus 1 by 3, and this will be minus 5 by 9. So it will be plus 5 by 9 on this side, equal to 12 plus 100 by 9. Okay. Now you can solve for VA. Once you get this VA, you can calculate this I. You can put it here, okay? You'll get the value of I. Is it fine, guys? So this was easy peasy again, okay? I mean, it's a nodal based question. I have written direct nodal equation, okay? Once you write this direct nodal equation, then you can put this I value in terms of VA and simplify. First calculate VA. Once you get this VA, you can calculate the I value. I hope you understood it. Can I proceed, guys? Tell me. Can I proceed? So this was again easy peasy question. Let's come to the next question. In the circuit shown below, excuse me. Yeah, in the circuit shown below, the switch is closed at t equal to 0. Okay, at t equal to 0, the switch is closed. The value of theta in degrees, this theta, okay, this theta is asked. This is 150 sine of 377t plus theta. I don't know whether it is like this or maybe something else, but I think it's 150 sine 377t plus theta. Anyway, okay, the value of theta in degrees, which will give the maximum value of DC offset of the current at the time of switching. Okay, so he's saying it's based on AC transient. Okay, this question is based on AC transient. He's saying that if you try to close this switch at t equal to 0, okay, now what should this theta such that the transient current get the maximum value? Okay, the DC current means the transient current. Theta in degrees, which will give the maximum value of DC offset current. Okay, it will provide the maximum value of DC offset current. Now, how to write the current equation? Can you tell me how to write the current equation? In AC transient, the current equation will be IT will be equal to Vm by Z sine theta Z sine omega t minus theta Z. Wait a minute. This sine of omega t plus theta, because this theta is given minus theta Z. This is the steady state current. Z is the impedance of this load. Okay, this is the steady state current. Now at omega t equal to 0, we have this value, no, Vm by Z. At omega t equal to 0, we have Vm by Z sine of theta minus theta Z. We have this value. So at omega t equal to 0, it has to be 0. Why? Because initially there was no current in the inductor. So the total current has to be 0 at t equal to 0. As soon as you close the switch, the current has to start from 0. So at omega t equal to 0, this is not 0. To make it 0, this current will come into picture and this will decay exponentially. Is it fine, guys? Okay, this is the equation for the current. Now we call it DC offset current. This is the value of this DC offset current. Now he is saying what should be this theta such that you get the maximum DC offset. Now you will get maximum value of this when this internal angle, that theta minus theta Z, came out to be 90 degree. Okay, if it is 90 degree, then you can say that this will be maximum. Is it fine? Is it fine, guys? Is it fine? Because if this is 90, then sine 90 is 1, so you'll get the maximum value here. Is it fine? Now how to calculate this theta Z? Once you get this theta Z, you'll get this theta. Is it fine? Is it fine, guys? Yes. Now you can calculate this theta Z first. So this theta Z, you can put it here. There is one more way. It should be 90 or 270. It can be 270 also, because if this is 270, then also it will become minus 1 and it will become the maximum value. Okay, the DC offset will be the maximum. Okay, so it can be of 90 or 270. Now what is this theta Z? Theta Z is equal to tan inverse of omega L by R. Omega is 377, L is 10 millihenry divided by R is 3.77. Okay, so this is cancelled with this and you'll get 100 here. So tan inverse of 1 is 45 degree. So theta Z came out to be 45 degree. Theta Z is 45 degree. So if theta Z is 45 degree, then theta will be equal to 135, or just add 45 degree to it. So it will be 315. Okay, it can be 135 or 315. 315 means minus 45. Okay, so answer is minus 45. D. Answer is Delhi. Sir, exponential वाला term कैसे लिखा नहीं समझा. Okay, it means your AC transient is poor. If you have not understood this part, it means your AC transient is poor. Let me explain. Let me explain how this happens. Let's say I have an yes, this is the free. This free space is here. Let's say I have this circuit now, R and L. Please watch my lecture on AC transient. And let's say this is the circuit we have. This is Vm sin omega t, let's say. Vm sin omega t plus theta. Let's say this is this. If you close the circuit at t equal to 0, I need to write this current equation, IT. How to write the current equation? Look, this current has two parts. One is IT steady state and one is IT transient. IT transient. Now, how to calculate this steady state part? First, we will calculate this steady state. Now, steady state part is easy to write. How to write the steady state? That is Vm sin omega t plus theta. This is my voltage. Divide by the steady state impedance. The steady state impedance of this circuit is R plus j omega L. R plus j omega L can be written as Z angle theta Z. Okay? Z angle theta Z. So it will be Vm by Z sine of omega t plus theta minus theta Z. Okay? This is the steady state current. This is the steady state current. Now, if this is the steady state current, what is the transient current then? We know that at omega t equal to 0, when t is 0, then omega t will also be 0. At omega t equal to 0, this current has to start from 0 value because of this inductor. This inductor has 0 initial current. It means as soon as this switch is closed, this current has to start from 0 value. This current has to start from 0 value. It has to be 0. But if you put omega t equal to 0 here, it is not 0. Vm by Z sine of theta plus theta, theta minus theta Z is there. It is not 0. To make it 0, the transient current will come. Okay. So now the total current is steady state current, which is Vm by Z sine of omega t plus theta minus theta Z. Now at omega t equal to 0, this is not 0. What is the value of this function at omega t equal to 0? At omega t equal to 0, the value is Vm by Z sine of theta minus theta Z. This is the value of this current at omega t equal to 0. It means I need to make this current as 0. This current should be 0. But this steady state part is not 0. To make it 0, I have to subtract this current. At omega t equal to 0, its value is this, na? Vm by Z sine of theta minus theta. So the same current I subtracted. So that at omega t, it should become 0. At omega t, now it is 0. But this current has to decay. R by Lt. This current has to decay exponentially because this is the transient part. Okay, so this way you can write this equation. I can divide this omega and multiply with omega also. Okay, so that's how I have written this equation. We call this part as DC offset part. Okay, well, this part as DC offset part. Is it fine, guys? Have you understood it? Tell me, say yes or no. Tell me, guys, say yes or no. Is it correct? Can I proceed? Tell me, everyone. Can I proceed? I hope you understood it. Okay, let's proceed with the next question. Okay, the current I flowing through the circuit shown below. This current is asked. How to calculate this current? It's simple, guys. What you need to do is you can replace this circuit with its Thevenin equivalent. Okay, calculate the Thevenin equivalent. RTH and VTH. You can calculate its Thevenin equivalent. VTH, RTH, and here you connect 20 ohm and calculate this current. I think it's easy peasy. You can calculate the RTH and VTH also, or Millman equivalent. You can calculate whatever. Millman is again the same as Thevenin equivalent. Okay, so I think you can do it. I don't want to do this question. It's very simple. Okay, so it's pure wastage of time. If you know how to write the nodal equation, remove this, calculate this voltage, assume this as ground. If this is ground, this is VA, calculate VA by writing the direct nodal equation. Okay, you calculate VA, that will be the Thevenin voltage, and take the parallel of these resistances, you'll get the Thevenin resistance. Okay, I think you can do it. Let's come to the next question, question number 23. So in 23, a 0.1 microfarad capacitor is charged to 100 volt. Okay, we have 0.1 microfarad. capacitor, and it is charged to 100 volt. Okay, discharged through a 1000 ohm. So this capacitor is discharged through 1000 ohm. Okay, so we have 1000 ohm resistance. It is discharged via this. Okay, the time in millisecond required for the voltage across the capacitor drop 1 voltage. Okay, so if I connect it here, obviously the capacitor will discharge. In what time this voltage will become 1 volt? So what I need to do is I need to write the equation for the capacitor voltage. Initial voltage of the capacitor is 100 volt and the steady state voltage is 0. Time constant is RC. So what you can do is RC is this into this. So if you multiply it, you will get 1 over, this is 1 over 10 into 10 raised to power minus 6, okay, into 1000. Okay, this is my RC. So RC came out to be 1 by 10,000. Okay guys, this is my RC. Now I can write this equation: Vc infinity plus Vc0 minus Vc infinity e to the power minus t by tau, 10,000 t. Is it fine? This is the capacitor voltage equation. Now tell me, in what time this voltage will become 1 volt? I think you can calculate this time. Is it fine? So what I did is I have written the discharging equation. Initial voltage was 100. If this circuit will work for infinite time, then the steady state voltage of the capacitor will become 0, and the time constant of this circuit is RC. Okay, we have calculated RC. Now the equation, I have written this equation. How to write this equation? It is Vc0 plus Vc0 or Vc infinity, Vc infinity plus Vc0 minus Vc infinity e to the power minus t by tau. This is the capacitor equation, no? This is the capacitor voltage equation. You can check it. Is it fine, guys? So this is my capacitor equation. So I put these values, no? Vc infinity is 0. Okay, Vc0 is 100, Vc infinity is 0, e to the power minus t by tau. So this is the capacitor voltage equation, and we need to calculate the time in which this voltage become 1. So we can calculate the time from here. Okay, I think it's easy peasy. Let's proceed with the next question. So the next question is on your screen. In this question, what is asked is, this is V1t, V2t, V3t. Here you have P1, P2, RL, RL. Okay. Now the question is, here the voltage source is connected directly. Remember, in this figure the voltage V1 is 100 cos omega t. This is 100 cos of omega t. Okay, and V2 is 100 cos of omega t plus this 10 degree. V2 is 100 angle 10. Let's take cos as reference now. If you take cos as reference, it will be 100 angle 0. Okay, it will be 100 angle 0, and then it will be 100 angle 10, and V3 is 100 angle 5, 180 by 36. If you take 180 by 36, then it will be 5 degree. So 100 angle 5. This is 100 angle 5. Fine. Okay. So this is 100 angle 0. This is 100 angle 10. This is 100 angle 5. So now you have 3 voltages. The circuit is in sinusoidal steady state. R is much less than omega L. P1, P2, P3 has the average power output. It means the active power. This is P1, P2, and this is P3. Okay, I think this is missing. P3 is the active power. Which of the following statement is true? Okay, we need to calculate the active power. Okay, we need to calculate the active power supplied by the sources. How to calculate that? It is given that R is much less than omega L. Okay, now tell me how to calculate this. How to calculate this? If I assume that this point is 0 volt, then this will be 100 angle 0, 100 angle 10. This is 100 angle 10. Okay, now we need to calculate this P1, this P2, and this P3. Okay, and we need to check whether which one is positive and which one is negative. Okay, and it is about the active power. How to check? How to check, guys? Tell me. It is given that R is much less than omega L. If R is much less than omega L, then you can assume that wait a minute, I need to solve it, otherwise you can't say. Anyway, Let's try to solve it. First you calculate this current. Okay, it's simple guys. If somehow you can calculate these currents now, then it's easy. Okay, now how to calculate that? Let's call it Z angle theta Z. Z angle theta Z. So this will also be Z angle theta Z. Z angle theta Z. Okay, now first of all let's try to calculate this current. We call it I1, okay, and we call it I3, and we call it I2. Okay, now what is I1? I1 is 100 angle 0 minus 100 angle 10 divided by Z angle theta Z. Okay, now what is this difference? If you calculate this difference, this will be 100 angle 0 minus 100 angle 10. Okay, this came out to be 17.43 at an angle of minus 85 divided by Z angle theta Z. Okay, now this theta Z is approximately 90. How can you say that? Because R is much less than omega L. It means this angle is approximately 90. Now if you calculate this I1 will be equal to 17.43 upon Z, and this angle will be minus 85 minus this angle. It is approximately 90. So it means this will reach to let's call it maybe 85. Okay, let's call it 85. So this 85 and this minus 85, this 85 will come in the numerator, so it will become minus 170. Is it fine? I'm assuming that it's nearly equal to 90. It means 85. If it is 85, then take it in the numerator, so it will become minus 170. Is it fine guys? So you can say that this current is lagging by minus 170. Okay, now calculate the active power. So the active power is voltage RMS into current RMS, whatever this I1 is, whatever this RMS value of this current is, into cos of 170, and cos 170 is negative. So you can say that P1 will be negative. Okay, you can say that the P1 will be negative. Is it fine guys? So first of all P1 is negative. Only two options are there. Okay, P1 is negative. We have calculated this. P1 is negative. Now let's come to P3, because using P3 we can get the answer. In one option it is greater, in one option it is less. I hope you understood it. Tell me guys, have you understood it? Let me repeat this question again. This is 0, so this voltage is 100 angle 10, so this voltage will also be 100 angle 10 because it is directly connected here, and this is 100 angle 0. What I did is I calculated this current, this direction, so that I can calculate the power delivered by this source, because the positive current is leaving the current, positive terminal is leaving the current. So you can say that we can calculate this current first. So this current will be 100 angle 0 minus 100 angle 10 divided by this Z angle theta Z. Okay, so this difference I have calculated this. Okay, this difference is this. Is it fine? Yes, I think this difference is correct. 17.43 angle minus 85, and in the denominator I have Z theta Z. This theta Z is approximately 90. Okay, this theta Z is approximately 90. Why it is 90? Because R is much less than omega L. Theta Z is 10 inverse of omega L by R. Theta Z is 10 inverse of omega L by R. Okay, since R is much less than omega L, so it is approximately 90. So I have assumed it as 85 roughly. Okay, so this will come in the numerator, it will become minus 170. Now this current which is leaving this positive terminal, it has angle minus 170. Now if I calculate the active power supplied by this source, then the voltage RMS value is 100 by root 2 into current RMS value. Let's say it's I1. This is the peak value guys, divided by root 2 will be the RMS value. So that will be the I1 RMS, let's say, into cos of angle between them. If it is at 0 degree, it is at 170 degree, so cos 170, so it will be negative. So you can say that P1 will be negative. Now let's come to P3. Let's come to P3. Now tell me, what is this current? This current will be 100 angle 5 minus 100 angle 10 divided by Z angle theta Z. Now can you tell me 100 angle 5 minus 100 angle 10? Let me calculate this. 100 angle 5 minus 100 angle 10, and this came out to be 8.72 8.72 at an angle of minus 82.5. Divide by Z angle theta Z. Tell me guys, Z angle theta Z. It means this theta Z is again approximately 85. So it will come in the numerator, it will be again approximately minus 70, minus 170. It means this current is also at minus 170. Okay. So it means this P3 will also be negative. Okay. This P3 will also be negative. Is it fine guys? Have you understood it? Okay. This P3 will also be negative because this current will also be, the angle of this current will also be approximately minus 170. So voltage angle is 5 degree and current angle is minus 170. It means cos will be negative. Okay, cos will be negative. So the active power will be negative here. I hope you understood it. So this P3 will also be negative. Is it fine guys? Tell me. I hope you understood it. So this way you can solve this question. I think it's easy peasy. Let's come to the next question. Okay, this is a graph theory question. It is removed from your syllabus. Okay, this is not in your syllabus now. No. The graph of the network has 8 nodes and 5 independent loops. The number of branches. Okay, this is in your syllabus. Tell me guys. Tell me what is the answer. Tell me everyone. Do it yourself. Directly formula based. Okay. Do it yourself. Okay. This is simple. Let's come to the next question. In the 2-port network shown below, H11, we need to calculate H11. Okay. We need to calculate H11. How to calculate H11 guys? Yes, Ravi Shankar told L plus M minus 1. Okay. Okay, you can apply the formula and you can calculate. Anyway, yes. Now I need to calculate this question. I need to calculate H11. H11 is V1 upon I1 when V2 is 0. So what you can do is you sort it so that V2 becomes 0 and I need to calculate V1 upon I1. Okay, this ratio I need to calculate. How to calculate this ratio? What you can do is you can apply some voltage here. Let's say I apply some voltage 10 volt. Calculate this current I1. Okay, apply some nodal and calculate this current I1 and then 10 upon I1 will be H11. I think you can do it now. You need to apply nodal. Okay guys, V1 upon I1 is H11 na? So you sort it here, apply this V1, let's call it V1 10 volt, whatever you take, I mean 10, 20, 30, whatever. Okay, I selected 10 volt. So V1 is 10 volt, calculate this I1 and take this ratio, you'll get H11. Okay, so I think it's easy peasy, you can do it. Okay, I don't want to solve it because this is based on nodal analysis. Okay, let's come to the next question. Next question is the voltage VT across the terminal A and B shown in the figure. We have A here, B here, and this is VT. A sinusoidal voltage have the frequency 100 radian per second. Okay, the frequency is given when the inductor current IT is in phase with the voltage VT. Okay, he is saying that this inductor current IT is in phase with VT. Okay, the magnitude of impedance Z seen between the terminal A and B is, okay, he is saying that this voltage and this current are in phase. Now tell me what is the magnitude of the impedance. Obviously it will be purely resistive. Okay, it will be purely resistive, then only this voltage and current will be in same phase. Otherwise this voltage and current cannot be in same phase. First of all you have to understand this. Okay, when the inductor current IT is in phase with the voltage, the magnitude of impedance Z seen between the terminal A and B. So what you do is you make its imaginary part equal to 0 and calculate the real part. That will be the impedance. Let's calculate it. So first of all calculate this impedance. It will be 1 upon j omega. Omega is 100 C. 1 upon j omega C. Omega C is 10 raised to power minus 6. Okay, 1 upon j omega C. So it will be minus j 100. Is it fine guys? It will be minus j 100. So we have calculated this impedance. So now what I am going to do is take the parallel equivalent. So 100 into minus j 100 divide by 100 minus j 100. Okay, plus j 100L. Is it fine? This is the total impedance. Now what you can do is you make its imaginary part equal to 0. You make its imaginary part equal to 0 and calculate the real part only. You just calculate the real part only. That will be the impedance seen between A and B. So it's easy peasy. Okay, Calculate the real part only. I hope you understood. So let's realize this. Do the realization process. Okay, so if I do the realization process here, so it will be minus j 10 is to power 4 into 100 plus j10, 100 plus j100 divided by 100 square plus 100 square, okay, plus j 100l. Okay, I have realized this, na? I have done the realization process. Okay, we call it realization. So now look at the real part only. Look at the real part only, not the imaginary part. So real part is this j into this j. This will become the real part. So it will become 10 is to power 4 into 100. That is 10 is to power 6. 10 is to power 6 divided by 10 is to power 4 into 100. It will become 10 is to power 6 divided by 2 into 10 is to power 4. Is it fine? So it will become 50. Is it fine, guys? It will become 50. No, it's not rationalization. It's called realization, Ravi Shankar. Rationalization is this. Let's say I have root 1 upon root 2 minus root 5. So it's an irrational number. So what I do is I rationalize it. How to rationalize it? Just multiply it by root 2 root 5 divided by root 2 plus root 5. We call it rationalization. Okay, we call it rationalization. Okay, there is a realization process. How to realize something? Let's say I have this number 1 minus j. Now I'll call it realization. Okay, just by multiplying this 1 plus j divided by 1 plus j. Okay, we call it realization. Is it fine? Okay, so I told you that we need to realize this. So you calculate the real part only. That will be the impedance. The imaginary part has to be 0 because this voltage and this current are in same phase. This is under resonance. Okay, so I hope you understood it. Now let's proceed with the next question. Okay, so 28, question number 28. A 3-phase load is connected to a 3-phase balanced supply shown in the figure. We have a 3-phase load. This is the 3-phase load R, L and C. Okay, VAN. This with respect to this neutral, this point voltage is given as 100 angle 0. Okay, VBN. This point voltage is 100 angle minus 120. And this point voltage is 100 angle minus 240. It means 100 angle plus 120. Okay, it is provided to us. The value of R for 0 current in the neutral wire, it is 0 ampere. I need to calculate the value of R. I think it's easy peasy. You just apply this nodal. Now assume this as 0 volt. Okay, now this is the voltage across this R, this is the voltage across this J, and this is the voltage across this C. Okay, now calculate this current 100 upon R plus this current 100 angle minus 120 divided by 10 angle 90 plus this current 100 angle plus 120 divided by minus J10, that is 10 angle minus 90. Okay, and equal to 0. The total sum of the current is 0. You can calculate the value of R. I think it's easy peasy. Okay, do it yourself, guys. Let's proceed with the next question. In the next question, the voltage across the circuit in the figure and the current through it are given by the following expression. Okay, we have the expression of voltage. This is the voltage, this is the current. Okay, so voltage has DC component and the AC component. Similarly, the current has the DC and the AC component. Omega is given as 100 pi. If the average power delivered to the circuit is 0, okay, I need to calculate the value of X. How to calculate the average power? Parseval relation. Apply the Parseval relation here. So a DC component, multiply them. So it will be 25 plus 1 by 2 into voltage peak value. Voltage peak value is 10, rather minus 10, into current peak value is X, into cos of angle difference. What is the angle difference? Here it is cosine, here also it is cosine. So angle difference is 60. Directly you can see, because both the quantities are in cosine. So if both the quantities are in cosine, then you can directly take the difference. So angle difference is 60. Is it fine? Cos 60 is half. So you'll say 25 minus, it will be 2.5x. Is it fine, guys? That is equal to 0. This is the active power. This is the active. I have applied the Parseval relation. Cos 60 is half. Okay, so it's minus 2.5x. 25 minus 2.5x equal to 0. So from here you can calculate the value of X. So the X value is equal to 10. Is it fine? X came out to be 10. Okay, this was easy peasy. Let's proceed. Let's come to the next question. Let me see how many questions are there. Oh, okay, only 2 questions are left. I think we have spent 2.5 hours. Anyway, my health is not with me. Even then I solved this question. Anyway, it was interesting. A DC voltage source is connected to a series LC circuit by turning on the switch S at time t. Okay, we have a DC voltage source. Okay, we have a DC voltage source and connected to a series LC circuit. We have LC circuit. Okay, we have LC circuit. We connected DC source to a LC circuit by turning on the switch at t equal to 0. We have a switch here and we close the switch at t equal to 0. Okay, initial current is 0 and initial voltage is also 0. Which of the following circular loci represent the plot of IT versus VT? Okay, we need to look at the voltage and the current plot. We know that the current will be sinusoidal. In this case, it's a pure LC circuit. In LC circuit, if you apply a DC source, the current will be, let's say this current, this is Vs. Vs root C by L. If you apply Laplace and if you try to solve this current IT, Vs root C by L sine of omega t. Okay, this is the current equation. And what is the voltage equation? Voltage across this capacitor. So voltage across this capacitor will be, what is the voltage? It will be Vs minus Vs cos of omega t. You can apply the Laplace transform. Okay, using Laplace you can see that. Okay, I think this is correct. At omega t equal to 0 it is 0, pi by 2 it is Vs, at pi it is 2 Vs. Yes, I think it's correct. You can check it using Laplace transform. You apply the Laplace transform. Now you will ask me, sir, how do you know this? Because it is power electronics. Okay, that's why. In power electronics you have so many LC circuit and a DC source. Okay, so that's why I remember it. Otherwise no point to remember. You can apply the Laplace transform and you can check it. So this is the current, this is the voltage. Now I need to plot the wave shape. Vs, what is Vs? Vs is not given. How it is saying 5? I think Vs should be provided in this. Something is missing. Anyway, now it is a sine wave. Current is a sine wave. So initially at t equal to 0, current will be 0. At t equal to 0, current will be 0. And the voltage is at 5 volt. So we need to check that option in which current is 0 and voltage is 5 volt. Look, in this circuit, if you see carefully, then at t equal to 0, which point should be there? No? Which point should be there? I think it's not correct. It's not correct. How can you say that? Wait a minute. Okay, okay. What you can do is you call it IT. Okay, and you call it VT. Okay, you call it IT, you call it VT. Take this Vs on this side, Vt by Vs, or rather you find cos omega t from here and sin omega t from here and try to find the locus. How to find? Sin omega t is, let's call it I naught. I naught by Vs root L by C. Okay, this is my sin omega t. Let's call it V naught. Cos omega t is equal to V naught, this is V naught minus Vs. So remove this minus, it will be plus Vs divided by Vs. Okay, is it fine, guys? This is my cos of omega t. Take this Vs on this side now. So V naught minus Vs and remove this minus. I think this should be minus. Is it correct? Please check it. I call it V naught now. I call it V naught. I have calculated cos of omega t. How to calculate? Take this Vs on this side. So V naught minus Vs is there. Remove that minus sign. Take it common. Remove that minus sign. So it will be Vs minus V naught divided by Vs. You get the cos omega t. Here you have the sin omega t. Here you have the cos omega t. Take the square, okay, and add it. So it will be 1 is equal to this square plus this square. So it will be I naught upon Vs root L by C. I naught by Vs root L by C. Take square of it plus Vs or Vs upon Vs is 1. Vs upon Vs is 1. 1 minus V naught by Vs square. Is it fine, guys? Is it fine? This is the locus now. I naught and V naught. We need to plot this locus. But I think, how can you plot it? How can you plot it? I mean, this locus is, yes, we get this locus, but there is no point of, I mean, how can you plot it? It's not correct. Okay, wait a minute. Let me raise. Okay, this is the question, guys. Let me read this question again. A DC voltage source is connected across series LC by turning on the switch S at t equal to 0 shown in the figure. Figure is not shown. Where is the figure? Okay, where is that figure? Figure is not given. It means something is missing. Okay, figure is not provided, guys. Figure is not provided. Circuit is not provided. I don't know what circuit is, where that figure is. I don't know the value of L and C. If you don't know the value of L and C, then you can't solve it, na? You can't write the current equation and the voltage equation. Okay, now check the original question, guys. Check the original question. Check the original question. I think, let me tell you the year. Let me tell you in which year this question was asked. Wait a minute. Okay, this question is asked in GATE 2018. Okay, yes, figure is also there, na? So there is a mistake. Okay, the typist has not made the diagram. Okay, let me give you the diagram. L is 1 Henry and C is 1 farad. C is 1 farad, and here is the switch, and here we have the voltage of 5 volt. Okay, okay, that's perfect. Okay, this is perfect now. So now the switch is closed at t equal to 0. First of all, I need to write the current equation. So the current equation is Vs root C by L. So C by L is 1, na? Sine of omega t, 5 sine omega t. This is my current equation. This is IT. Okay, now the voltage equation, the capacitor voltage equation. V is the capacitor voltage. Let me check. Yes, V is the capacitor voltage. So the capacitor voltage equation is Vt is equal to 5 minus 5 cos of omega t. Please check, is it 5 minus or 5 plus? Wait a minute, I think it is, I think it's minus. That's correct. I think it's correct. Okay, it cannot be plus. It should be minus. Yes, it's minus. Okay. So this is IT equation. This is voltage equation. You can check. You can use the Laplace transform to calculate this voltage. Okay. This is the voltage equation. This is the current equation. Now I need to check which locus is correct. V and I. Okay. So voltage can never be negative. If you look at this, voltage will always be positive. Voltage will go like this. Okay, voltage will always be positive. Voltage can never be negative. You can see that. And the maximum voltage will go up to 10 volt. Maximum voltage will go up to 10 volt. Is it fine? The magnitude of the voltage will go up to 10 volt. The maximum voltage. Here in this circuit, voltage is 5. Here voltage is again 5. So A is not correct. D cannot be correct. Oh, wait a minute. D need C. C cannot be correct. Is it fine? Okay, because the maximum voltage has to be 10 volt. And now the current cannot go beyond 5. Maximum value of the current is 5. Okay. Now I need to write the locus. How to write the locus? Let's call it I naught. Let's call it V naught. So I naught is equal to 5 cos of omega t, 5 sine of omega t. I naught is 5 sine of omega t. Now I can plot the locus. And V naught minus 5 or 5 minus V naught is equal to 5 cos of omega t. Okay. Now what you can do is you take square of on both sides. So you'll get I naught square plus 5 minus V naught square is equal to 5 square. So it's a circle equation. It's a circle equation. And the center will lie at 5 and 0. If x-axis is voltage and y-axis is current, then we can also write this as V naught minus 5, right? V naught minus 5. We can also say that this is V naught minus 5. So the center will lie at 5, 0, okay, and the radius is 5 itself. So I think Bombay is correct answer. Is it fine, guys? This is the equation for the circle, okay. So if this is the equation for the circle, then you can say that the center will lie at x-axis is voltage, na? So x equal to 5 and y equal to 0. So 5, 0 is the center and the radius is 5, okay. So this way you can write answer is Bombay. Let's move to the next question. The equivalent impedance Z equivalent for the infinite ladder. Okay, the Z equivalent is asked. How to calculate the Z equivalent? I think it's easy peasy. Okay, tell me guys, how to calculate the Z equivalent? Let's call it Z. Let's call it Z equivalent as Z. You can see that this ring is repeated again and again. This is repeated again and again. So if the total equivalent is assumed as Z, and if we remove this first ring, then also the equivalent impedance of remaining ladder is again Z. So what you can do is J9 here, and here you can combine them. If you can combine them, it will become J4. Okay. Now the equivalent is Z. The equivalent is Z. I removed this first ring, and the remaining ladder will also have the same impedance Z. Okay. We need to calculate this Z. How to calculate this Z? It's very simple. Just multiply them. Okay. J4 into Z divided by J4 plus Z. Okay. This is the total equivalent of this, plus J9 is equal to Z only. Okay. Now take this J9 on this side. So J4 into Z divided by Z plus J4 is equal to Z minus J9. Is it fine, guys? From here you calculate the value of Z. It's easy peasy. Tell me guys, साहिल सोनी, आपका टेलीग्राम का डाउट भी बता देंगे भाई. मेरी तबीयत पिछले 5 दिन से खराब चल रही है. आज भी मैं बीमार हूँ. 10, 102, 101 डिग्री बुखार चढ़ा हुआ है. ठीक है, पिछले 6 दिन से. Actually, I have visited Delhi for some reason, and after that I got some cough, and because there we played cricket game with BYJU'S all the faculty. Okay, so I was also there. Though I was, I couldn't play because I got bowled on the second ball in both the matches. But because of that fielding, I got some, you can say, I got fever. Okay, and then cough and then everything. So that's why. Right now I'm teaching by taking medicine. So anyway, it's difficult for me. So okay, let's come to the question, guys. Tell me, what is the answer? What is the value of Z here? You can calculate the value of Z. Okay, you can calculate the value of Z. Check which option is correct. Okay, Z will be purely inductive, no? Z will be purely inductive because everything is inductive. This is J9, this is J4, this is J9, this is J4. So Z will be again inductive. Or what you can do is you can remove this J. You can remove this J here because we know that the answer is inductive, no? So you can remove this J. We can replace, whatever the answer you will get here, we will put J along with that now. So you don't take this J now. Why to complicate this? Okay. Why to complicate? Remove this J first. Okay. Now you can check the value of Z. Whatever Z you get, put J along with that. Okay. So it will be 4Z equal to Z square minus 5Z minus 36. Is it fine, guys? Z square minus 5Z minus 36. I think it's correct. So Z square minus 9Z minus 36 equal to 0. Can you calculate the Z value here? Tell me the Z value. I think Z is 12. Okay. Z came out to be 12. So the answer is J12. Answer is J12. Is it fine? So it's easy. Okay. So answer is J12. So this was the last question, guys. I hope you enjoyed this session. Okay. I hope you enjoyed. And that's all for electrical engineering student. Tomorrow we'll take for ECE. Okay. Tomorrow at the same time we'll take question from ECE, network theory. We'll again try to solve, and we'll solve the questions from ECE. Okay. Today I have taken 5-year questions, last 5-year questions from EE only. Okay. in the next class we'll take questions from ECE. Okay, so see you on tomorrow. Yeah, sir, मैं अपना एनालॉग का good question वाला वीडियो देखा and it helps a lot in revision. Thanks. Okay, class corner, that's great. You can watch my sessions on every subject because I have taken some DPP courses on analog and machines and power system, power electronics. Okay, almost on each subject I have taken some DPP courses. Okay, DPP classes. So you can check DPP power system by Ashu Sir. You can search this on the YouTube and you will get those videos and you can practice those questions. Okay, those questions are above gate level. You can say 4 to 5 times difficult than gate level because you can see that the gate is very easy. The gate level is very simple, very easy. Okay, I mean these questions are very easy. If you have good practice, if you have prepared the subject well, then you can easily solve these questions. Okay. Yes, class corner. Tomorrow we'll take questions from ECE. Okay, because today I have taken questions from EE. Anyway, I hope you enjoyed. So let's stop it here and don't forget to install this app, BYJU'S Exam Prep mobile app. So go to the Google Play Store and install it because on mobile app also we'll provide some sessions and you can also attend those sessions and solve the questions. So I think it will be helpful. So please install this app and take care. तो पढ़ते रहिए, मुस्कुराते रहिए. कल मिलते हैं next session में. EMFT and measurement. Shall I leave for the exam? No, you don't need to leave it, Rahul Sharma, because you have enough time. No? 1 month is enough for both the subjects. You can cover them. Moreover, in measurement only specific subtopics are there. No? You can just prepare those topics only, like wattmeter method, like CRO Lessage's pattern, and how to increase the range of voltmeter and ammeter. Okay, so simple. You can prepare those topics only. I mean, prepare the specific topics. Similarly, in EMFT, you can prepare the specific topics only. Rather, if you want to prepare the full subject also, you can prepare it because it's 1 month. And in 1 month, you can easily, if you can devote some 4 to 5 hours on those subjects, you can easily complete that subject. So it's not a difficult task. Don't leave it. Because EMFT, if you look at the pattern from last 4-5 years, the pattern is like they are asking from 5 to 6 marks question from EMFT. Okay, so don't leave it. It's very important. And if you are from EC background, then you must prepare EMFT. Okay, because EMFT is a core subject for EC background student. Okay, sir, digital छोड़ दूं क्या sir? No. In digital, you just need to prepare 3 topics. That is Muxis, K-map, Boolean algebra, and sequential circuit like JK flip-flop, SR flip-flop, and simple. Okay, only these 3 topics are required. So why to leave it? Okay, I prepared digital exam last 6 days, last 7 days of exam. Okay, you are not a kid. Don't think that I have to stop the study now because only 1 month is left. So now I cannot read the new things. You are not a kid, yaar. You are not preparing for JEE. You are not a small child. Okay. Now you are an engineer. You have to study till the last day. Okay. So don't leave it. Start preparing the subjects. Okay. Everything is easy. It's not difficult. Don't leave it. I hope you understood it. Anyway, sir, बहुत लोग बोलते हैं 1 month दो नोट स्टडी नहीं हो. वो लोगों ने कभी गेट नहीं दिया. मैं आपको बता देता हूँ. Okay. जो लोग ये बोलते हैं वो बकवास मारते हैं. वो उन लोगों ने कभी गेट नहीं दिया है. पता नहीं क्या है वो 10वीं बार रैंक 1 निकाली होगी या रैंक 2 निकाली होगी. पता नहीं. ठीक है, मुझे नहीं पता. बट उन लोगों ने, मुझे लगता है कि ऐसे लोग जो बोल रहे हैं उन्होंने कभी गेट दिया ही नहीं. ठीक है, आपको आखिरी दिन तक पढ़ना है. ठीक है, मैं आपको बता देता हूँ लास्ट डे तक, टिल द लास्ट डे. यू आर नॉट ए किड, यू आर नॉट ए स्मॉल चाइल्ड. ओके, वासुदेव जी बोलते हैं. वासुदेव कुछ भी बोल सकते हैं भाई, उनका अपना है हिसाब किताब. ठीक है, वासुदेव का तो कुछ कह नहीं सकते ना. वासुदेव स्वयं वासुदेव है, प्रभु है वो, तो प्रभु तो कुछ भी कह सकते हैं ना फिर. ठीक है, तो इसलिए परेशान मत होइए. वासु जी बोलते हैं दिसंबर 30 तक लास्ट है. पागल है, मूर्ख आदमी. ठीक है, उनको बोल देना, मेरी क्लिप भेज देना ये. ठीक है, मूर्ख है वो. ठीक है, दिसंबर 30 लास्ट डेट का किसने बोला? दिसंबर आखिरी तारीख जो है, जिस दिन आपका पेपर है उससे आखिरी दिन पहले, वो है आखिरी तारीख. ठीक है, बस आपको मैं बता देता हूं, कुछ भी है. ठीक है, मजे मत लिया करो भाई आप लोग. ठीक है ना. चलिए, चलिए तो आज के लिए इतना ही करते हैं, ठीक है। नेक्स्ट क्लास में फिर से आपसे मुलाकात होगी। अपना ख्याल रखिए, पढ़ते रहिए, मुस्कुराते रहिए। कल मिलते हैं। थैंक यू एंड टेक केयर, बाय।